Hello everybody, my cute cuties. எல்லாருமே ஹாப்பியா சேஃபா இருக்கிறீங்களா? Hello. Please let me know in the chat box, guys. Hi, hello. Yes. Galaxy, Deepak, very good, San. Okay, perfect. Believe in yourself. Hi. All good. Okay. Hi, Darshu. Okay, fine. Okay. So, we are going to cover few chapters. Okay, so I have planned for 4 chapters. First one the electromagnetic induction, second one the alternating current, and third one the wave optics and ray optics. As I mentioned, recently we have done that. So if you need a quick revision, I will be uploading, today or tomorrow you will be getting the 10 minutes quick revision also. Otherwise, na 19th we have the long marathon is there. So anneki vante you can attend that also. During that time also we will be going for a quick revision. Okay va? And dual nature also. These are the 4 chapters we have targeted for today. And sorry for the delay. Inneki vandu konjam works irundirichu. Yes, adinala da I was just bit late. Sorry for that. Okay, start after 100 likes. So we should wait for a little bit long time. Okay, so in 5 minutes we are going to start the session. Okay, so you people have to do one thing. Friends oda solliko, like Lerin Mam oda class irukku, idudha the last chance. 4 chapters in the session la cover panna pore. Quick we are going to revise the content. Okay va everybody? So marakama like paniko, share paniko, subscribe paniko. Yena channel la vande not just physics, you are going to get chemistry, biology classes as well. And in the channel vande Neet channel. Adanala Neet preparation, if you are targeting for Neet preparation, idha right place. Okay va? So adanala definitely you should subscribe the channel. Okay va? Got it? Yes. Everyone, I'll give you more time. Okay, friends, you should call your friends and make it 50 like for now. At this moment we need 50 likes. Adukapra 5 minutes kapra we can think about 100 likes. Yes, of course, Vinish, we are doing the sample question papers. I have made few question papers, so we can just work on that as well. Yena in the time la vandu question paper, full stretch question paper solve pandrathu romba important. Yes, Darshu, Tricky, and Bhavish, right? Srinivasan. Yes, hi. So, likes, we need more likes, everybody. Yes, you people are very kind and everything, because 15 is 55 kodukra. Okay. So, ipo vande, as I mentioned, inneki vande we are going to cover almost 4 chapters. Other than our target. Okay, so what are the chapters we are not covering in this 2 days? Okay, we will be covering on which day, guys? Which day? And the mega marathon la we will be covering everything. Okay va? Topper Siva is here. Okay. Anyway, tricky friend is saying we can start. Arambikalama, guys. Give me a thumbs up in the chat box, everybody. Arambikalama. Atoms and nuclei we will be covering on 19th. Okay, it is a small chapter and we will be focusing on 19th. Okay va? No worries. Okay, and semiconductor chapter 10 minutes quick revision also you will be getting quickly. No point of I have fear, I have scare, adaledo meaning e kedayadu. Okay, just be confident. Whatever you have done, that will help you. Okay, and don't expect any magic miracle thing for your exam. Okay, I have studied 2 chapters and the 2 chapters la irundhu mattum the questions varu. Won't happen. Okay. So fine. And yesterday we have taken few chapters. Adoda notes, I hope you guys have it. And the short notes in the exam time, exam last minute revise pandradhukku you can use it. And also when the mind maps in the channel already it is given. So you can download those mind maps as well. Okay. So after the session, I will be sharing a sample question paper, and the session it will be after this live session only it will come. So you can download that sample question paper also. Of course you can. Okay, va? Aarambikkalama. So if you are ready, give me some fire on the chat box, everybody. Everybody. I need more fire. I need more energy. Yes, perfect. Okay, cool. Okay. So, we are just going for the, okay, perfect. Okay. So, we are going for the first chapter, electromagnetic induction. So, first we should know what is this electromagnetic induction. Okay. In the EMI na enna. Okay. We should know electromagnetic induction, EMI. So, இப்போ electromagnetic induction producing EMF or generating EMF. Okay, generating EMF using change in flux. Okay, flux change panni we are generating EMF. Adu tha and the process that is known as the electromagnetic induction, generating EMF using the change in flux. இப்போ first one Faraday's law. Okay va? இப்போ first one we are going for Faraday's law. Faraday's law now very simple, whatever we have said. Okay, in the EMF, magnitude of EMF, okay, magnitude of EMF it will be equal to rate of change of flux. Okay va? In the magnetic, in the induced EMF, in the induced EMF is equal to rate of change of flux. Appo I'm just thinking about flux. Flux na enna guys? It is a scalar quantity and it is nothing but B dot A. And adoda unit Weber. Okay va? Adoda unit Weber. Got it? So, இப்போ 5 we have, 5 is equal to B dot A. Illana we can say it is nothing but BA cos theta. Okay? 5 we understood. So, இப்போ induce EMF. If we need to induce EMF na, what we need to change? Either we can change the magnetic field, or otherwise you can change the area, or otherwise you can change the angle between B and A. இப்போ I wanted to know one thing. Okay, in the area vector direction enna? Area vector direction enna? Comment me. Give me the answer in the chat box. In the area vector direction enna? Tell me. Area vector direction. You guys know it. Very good, Darshu. Very good. It will be always perpendicular to the surface. So, if we have a field and this area, and if we are changing the orientation, if we are making an angle change, then also in the flux change pandradhukku, we can change the flux. Okay. So, in the flux will change if we are changing the magnetic field, and if we are changing the area, or let's say if we are changing the orientation. So, in the three things in the flux change pandradhukku we can go for it. Ana Faraday's law it will be, he was saying only about the magnitude of the induced EMF. So, இப்போ in the induced EMF oda direction kuda theriyano. So, adukkaga we are using the Lenz's law. Okay, Lenz's law. So, in the Lenz's law is based on the conservation of energy. Okay, conservation of energy. Yena, we understood one thing. Let us say we have a current carrying coil. Okay, wow. So, we have a current carrying coil. இப்போ வந்து what I'm going to do, current carrying coil na adula magnetic fields irukum. இப்போ வந்து I'm going to do one thing, I'm going to take a magnet. Okay, I'm going to take a magnet towards the coil. புரிஞ்சுதா? Everybody listen. So இப்போ வந்து we are talking about the induced EMF ஓட direction. அது we are going to talk about that. So அப்படினா we can say that இப்போ வந்து we have a coil over here. Okay வா? இப்போ வந்து ஒரு coil over here. So அதுல வந்து we are going to insert the magnet. So இப்போ வந்து இந்த magnet insert பண்ணும்போது what will happen? We have mentioned flux na enna guys, it is nothing but the flow of field lines, correct? So inga vandu magnetic flux na flow of magnetic field lines. So appadina I can say that when we are inserting or when we are keeping this magnet towards the coil, enna agum and the field lines vandu cut agum. Field lines vandu cut agum means in the flux change aga pore. புரிஞ்சுதா? So basically if we have a coil and we are taking the magnet, in the field lines vandu cut agum, which means what will happen? Flux will change. Correct? Flux will change. Flux will change now. What is the meaning? Flux changes now. What will happen? Induced EMF produce agum. புரிஞ்சுதா? Hey, என்னென்னலாமோ நடக்கிறது. எப்படிரா? What is this? Okay, so right now ignore few things and focus on the class. Okay va? Okay, just ignore. If you are responding only, then this problem will come. Forget it. Okay, so ipo vanda we have the magnet which we are keeping close to the coil. Appo vanda in the field lines cut agum, flux change na definitely induced EMF produce agum. So ipo vanda in the induced EMF vanda selfish. Okay, selfish. Okay va? So in the induced EMF will try to oppose. It doesn't want any flux change. ஏனா அதுக்கு வந்து company எதுவும் தேவையில்லை. Okay, in the induced EMF வந்து it will do one thing, it will oppose. It doesn't want more induced EMF. Okay, induced EMF produce na current will be produced. So adanaala in the induced EMF adoda selfish behavior nala it will oppose the more flux change. Okay va? So it will oppose the more flux change. Marakama like panniko. Okay, don't be selfish like this induced EMF. Everybody, okay? So ipo vanda we understood in the induced EMF will oppose the flux change. அதனால as per the Lenz's law we can say that in the induced EMF வந்து minus d phi by dt. In the induced EMF will produce in the opposite direction of flux change. ஏனா it will always oppose the flux change. So இப்போ வந்து in the north pole. Okay, north pole is coming towards the coil. Okay va? So just imagine, I want the answer in the chat box. Listen carefully. Everybody listen here. Everybody, I want your attention here. இப்போ வந்து north pole is coming towards the coil. What is coming? North pole is coming towards the coil. Okay va? So இப்போ வந்து north pole. Okay? And this induced EMF will oppose this motion. Because yeah, in the magnet, if it is coming again, what will happen? If it is coming again, what will happen? More flux change will happen. And in the induced EMF, it is not, it doesn't want it. So adinala we can say that if in the north pole vandena definitely to oppose this north pole. Okay, to oppose the north pole in the coil, in the near end, which pole should be there? North. To oppose north, like poles will repel. அப்படினா இந்த coil near until it is going to be very good. North polarity will be induced. North pole will be induced. புரிஞ்சுதா? Very good guys. Very good. Kallus is there. Samiha is there. Yes, Arjun is there. Yes, learning master is there. Sweetie. Today's target வந்து எல்லா டேக்கும் we will be having some targets. Okay, so இப்போ வந்து we will be focusing on electromagnetic induction. அதுக்கப்புறம் we will go for AC. அதுக்கப்புறம் we will go for wave optics. அதுக்கப்புறம் we will be going for this dual nature. Thank you Galaxy. If you are saying this, I won't tell this. Okay, so இப்போ வந்து we understood in the north pole oppose பண்றதுக்காக இந்த current, இந்த current carrying coil வந்து ஒரு north pole induce ஆகும். north pole induce ஆகும்னா current வந்து anti clockwise. புரிஞ்சுதா? current வந்து anti clockwise direction ஆகும். To produce the north pole. Anti clockwise na it is representing north pole. Okay va? So இப்போ வந்து I'm overcoming this and I'm just taking this magnet inside. So அப்படினா again what will happen? Now the thing is like if this magnet is moving back, again flux change will happen. Listen, north pole is already inside the coil. Okay, flux lines எல்லாம் கட் ஆச்சு, flux induced EMF produce ஆச்சு. இப்போ வந்து இந்த magnet, if we are going, if we are releasing it back, என்ன ஆகும்? Again more flux change will happen. அப்போ வந்து இந்த coil will do something. What? Okay, it wants it. What is the point of this induced EMF? Induced EMF will be thinking, okay, it should not move. It should not move. அதுக்காக in the north pole, it does not move. அதுக்காக which pole will come there? Which pole will come there? Which pole will come there? North pole. So definitely south pole will be induced at that moment, and we can say that this north pole and south pole will be get attracted. Adinala we should do some work to remove it back. Very good, very good, very good. Okay va? So இப்போ வந்து I'm just telling you again, north pole we are keeping it close to the coil. அப்போ வந்து இந்த coil will produce a north pole to repel. ஏனா அதுக்கு changing flux வேணாம். Okay, it does not want the change in flux. அதுக்காக இந்த magnet stop பண்ணனும். அந்த stop பண்றதுக்காக what we will do, what this coil will do, it will flow in the anti-clockwise direction and it will be inducing the south pole at the near end. அப்போ வந்து repulsion. Now what we have done some work. Okay, we have done some work and we have kept inside. So அப்போ வந்து again if it is releasing back now, what will happen? Again there will be flux change, again there will be induced EMF. அதனால it will be the current will flow in the clockwise direction, which means south pole. So if let's say if we are just going for the south pole now, what will happen guys? If you are going for the south pole, definitely firstly it will be at the near end it will be producing the south pole clockwise direction. Adukapram if you are doing the work, then what will happen? Again there will be a EMF is produced. So now the thing is like in the south pole it does not move. Adukaga it will produce a north pole. Okay, understood? So இதுதா வந்து concept. So இப்போ we understood we are doing some work. Okay va? We are doing some work against this. அந்த work தான் actually இந்த EMF store ஆகுது. அதுதான் வந்து law of conservation of energy. அதுதான் இந்த physical significance. Okay, the work we are doing to overcome the repulsion, அதுதான் இந்த EMF store ஆகுது. அதுதான் வந்து we are saying conservation of energy. Okay va? புரிஞ்சுதா? Everybody understood? Okay, and இதுல வந்து we should know the units as well as the dimensional formula. Everything is important. Next வந்து motional EMF. Okay, again listen, another important point. Okay va? So இப்போ வந்து we are talking about the motional EMF. இது வந்து ஒரு conductor. Okay, so now let's say the field வந்து towards you. Clear-ஆ புரிஞ்சுக்கோ, note பண்ணிக்கோ, ஏன்னா இந்த concept important தான் to solve the problems. Okay va? So இப்போ வந்து இந்த conductor இருக்கு, இந்த conductor I placed in a magnetic field, and the magnetic field ஓட direction என்ன? Towards you. Understood? Now I am doing one thing, I'm just making it to move. புரிஞ்சுதா everybody got it? Yes or no? Okay, so இப்போ வந்து we have a conductor that is moving in a magnetic field. The direction of the magnetic field is towards you and it is moving with a velocity v. So அந்த டைம்ல just imagine this is the conductor we have. Okay va? This is the conductor we have and the field will be towards you. Okay, field will be towards you. இப்போ வந்து இதுக்கு ஒரு velocity இருக்கு. So அப்படினா definitely இந்த conductorsல charges இருக்கும். If I'm saying this conductor is moving with a velocity na, இதுக்குள்ள chargeum அந்த velocityல move ஆகும். Okay, இப்போ வந்து I'm telling you, I mean all of us are sitting in a bus. And the bus வந்து it is going with 40 km/h. அப்படினா we can also say we are also moving in 40 km/h. அப்படினா I can say that in the conductor velocity v na, இதுக்குள்ள இருக்கிற chargeக்கும் I mean what will be there? In the chargeக்கும் velocity இருக்கும். புரிஞ்சதா? Everybody understood? In the chargeக்கும் velocity இருக்கும். So இப்போ வந்து you should tell me one thing. Okay, you should tell me one thing. இந்த கண்டக்டரோட length வந்து L. Okay, கண்டக்டரோட length வந்து L. Okay வா? So இந்த charges, okay, இந்த chargeோட direction என்ன? Okay, in the charge it will experience a magnetic force. Okay, it will experience a magnetic force. And the magnetic force ஓட direction என்ன? Let me repeat again. Conductor இருக்கு, அதுக்கு ஒரு velocity இருக்கு, and the field is towards you. அப்படினா அதோட magnetic force, அந்த சார்ஜுக்கு experience பண்ற magnetic force ஓட direction என்ன? What we will do? We have the Fleming's left hand rule. Use the Fleming's left hand rule. Use the Fleming's left hand rule. Everybody. So, father, mother, children. Correct? Father, mother, children. So, அப்படினா you should tell me. Father na magnetic force, mother na magnetic field, and this children na what is children? Current. So, tell me what will happen? What will happen? So, current order direction, you can take it as the velocity. Forgot this law. Fleming's left hand rule. Very simple. இது வந்து magnetic force. Okay, இது வந்து magnetic field. இது வந்து current. So அப்படினா what will happen here? What will happen here? So let us say this is the velocity, okay, and magnetic field வந்து towards you, and current I'll be taking in the direction of velocity, and magnetic force வந்து upwards. Correct? We are using the Fleming's left hand rule. So we know the field is nothing but the forefinger that is towards you, and the velocity direction, that is what the central finger, and this thumb will give you the force direction. அப்படினா upwards. That is for a positive charge. இப்போ வந்து இந்த conductorல we will be having only free electrons. Correct? In the conductorல we will be having only free electrons. Free electrons na negative charge. அப்படினா அந்த force ஓட direction என்ன? Please give me in the comment box. Positive charge na அதுக்கு upwards da direction வருது. அப்படினா இந்த negative charge க்கு what is going to be the direction? Tell me. Tell me everybody. Positive charge க்கு upward na, negative charge க்கு downwards. So which means the free electrons will experience a magnetic force, and that is due to the motion of the conductor, and the direction will be downwards. புரிஞ்சுதா in the concept? Yes, very good guys, very good. So in the concept புரிஞ்சுக்கோ. இப்போ வந்து we have a field over here. And I'm keeping a rectangular frame. Okay, I'm keeping a rectangular frame over here. Okay, I'm keeping a rectangular frame over here. In the length one the L, and here I'm taking it as X. And now I am taking one more conductor on the fourth side. Okay, இப்போ வந்து எனக்கு I can do one thing. Okay, என்ன எனக்கு முடியும்? I can just move this fourth conductor. Okay, I made a frame, a rectangular frame. Okay, அதில இந்த fourth one I can move. அதனால தான் I have given this distance as X. அது வந்து vary. Okay, it will vary. So இப்போ வந்து we understood it will experience a magnetic force. ஓகே அது வந்து அதில் வந்து வேரியேஷன் இருக்கும் அப்படின்னா அங்கே ஒரு இன்டியூஸ் இஎம்எஃப் இருக்கும் ஸோ அந்த இன்டியூஸ் இஎம்எஃபோட ரிலேஷன்னா மைனஸ் d∅/dt அப்படின்னா we can say d/dt of BA cos theta. புரிஞ்சுதா புரிஞ்சுதா everybody புரிஞ்சுதா ஸோ இந்த கேஸில் வந்து இந்த B and A okay B and A வந்து it is going to be 0 degree okay field is inside and the area vector the plane will also have a direction in the same way அப்படினா we can just go for theta is equal to 0 degree okay so இப்போ வந்து I'm going to write d/dt of B into area na enna guys tell me area na enna in the plane oda area na L into X ipo vanda in the B magnetic field will be same length L is not going to change only this X is varying so I can just say that dx/dt and we have a minus sign over here okay va understood so ipo vanda you should tell me what is dx/dt displacement divided by time na enna guys displacement by time na enna what is going to be that it is velocity very good so appadina I'm just writing minus BL and the velocity oda direction vanda if I'm taking here I will write minus V appadina induced EMF vanda BLV ana ipo vanda I'm making the velocity towards here in the case la vanda induced EMF will be BLV purinjudha everybody purinjudha so this is what is happening in the motional EMF marakama like panniko share panniko subscribe panniko telegram la join panniko don't forget okay can we expect 100 likes now in 1 minute okay Nashu we can just think about that on 19th okay 19th also I don't think I will do derivation let me just check in if any possibility I will do as a separate session okay thank you okay everyone those who forgot to like now Yana we need to make it 100 likes we can make it right yes or no yes Mithun is there Darshu Kallus okay pretty good so ipo vanda we got this what motional EMF இது வந்து depends upon the velocity oda direction depend பண்ணிருக்கு ஓகேவா and we will say this as a scalar triple product இது வந்து we will call it as scalar triple product அப்படினா we can say in the induced EMF வந்து V cross B dot L so in the relation you should study okay va so in the session vanda exam oriented specific we will cover the important points and important topics and idu vanda detail and the level based session edu illa so you can just watch this if you need a quick revision so ipo vanda we have done for the what to say a conductor in a external magnetic field will produce an EMF adu vanda BLV இப்போ வந்து we have a rotating rod okay we have a rotating rod so அப்படினா what will happen we need to replace velocity ஏனா rotating na we should replace velocity in terms of angular velocity okay va so இப்போ வந்து இதுதான் நம்ம road okay இதுதான் நம்ம road இதோட length வந்து let us say I'm saying r so இப்போ வந்து if I'm rotating this road what will happen இதோட radius அந்த rotationல அந்த circle ஓட radius வந்து இதோட length ஆயிருக்கும் so I can say that அந்த radius வந்து r or let's say இதோட length வந்து r ஓகேவா இப்போ வந்து we should know velocity in terms of angular velocity can you give me the answer in the chat box what is velocity in terms of angular velocity what is that we are doing learning master okay we have already done the live session I have clearly explained which are the days we will be focusing on everything Okay, so இப்போ வந்து we can say it is nothing but r omega. புரிஞ்சுதா? So இப்போ வந்து we will be taking a very small element over here dx. அப்படினா I can say that இந்த EMF வந்து இந்த small EMF வந்து due to the small segment and the EMF வந்து என்ன ஆகும் guys? You should tell me what is going to be the EMF. It will be there, Manoj, don't worry. இன்னைக்கு இந்த sessionல we will go for a quick revision. Okay. Okay, so in the small EMF என்ன ஆகும்? In the small EMF என்ன ஆகும்? B into and in the L, I mean instead of L we will go for dx, and instead of V I will go for, if the distance from the point, the pivoted point to the element we are taking, I'm taking it as x. So அப்படினா I can say it is nothing but x omega. இப்போ வந்து if you need to get the omega, I mean the total induced EMF, அப்படினா I should integrate both the side. So B வந்து constant and omega வந்து constant. So we will be having only x dx, and this will be, x will be varying from 0 to r. புரிஞ்சுதா everybody? Yes or no? Get me, I mean let me know in the chat box. இப்போ வந்து we have the velocity r omega, and on the induced EMF due to a very small element dx from the pivoted point, I mean the total distance is x. அப்படினா we can say we are replacing the equation BLV in terms of omega. இப்போ வந்து integration b omega x square by 2 within the limit 0 to r. அப்படினா we can say b omega by 2 x square வந்து r square. So இதுதான் வந்து EMF due to a rotating rod. இது வந்து important, you should study. Okay. Okay, va? All good? Yes or no? Okay. So இப்போ வந்து we have discussed about the what to say, the motional EMF, right? In the motional EMF la irundhu we can expect some questions also. So இப்போ வந்து you should do, I mean you should go for like as well as share, subscribe. Okay, இப்போ வந்து we are going for the self induction and mutual induction. Okay, so first வந்து we are going for self induction. இப்போ வந்து we have a current carrying coil. Okay va? இப்போ வந்து we have a current carrying coil. அப்படினா I'm just taking, first I will be just taking only one coil. Okay, number of turns is equal to 1. அப்படினா the current will be flowing through the circuit. Correct? Current will be flowing through the circuit. So அந்த டைம்ல definitely அங்க magnetic field produce ஆகும். Correct? இப்போ வந்து இந்த current is going for in the clockwise anti-clockwise direction na, in the magnetic field வந்து upwards இருக்கும். Okay va? So அப்படினா I can say that if a current is flowing through a coil, there will be an induced EMF, and this induced EMF will try to oppose the, again there will be, if this current is flowing like this, there will be a magnetic field. So this induced EMF doesn't want to get more flux change. அதனால it will oppose the current flow. அதுதான் வந்து we are calling it as back EMF. In the same coil, the current passes through the coil. என்ன ஆகும் guys? It will, when the current changes through the coil, there will be an induced EMF produced in the same coil. Same coil in the induced EMF will be produced. அப்படினா I can say that on the flux in the self induction it is visible, right? Yeah. In the self induction in the phi வந்து it is proportional to the current flowing through the coil. அப்படினா I can say phi will be equal to Li. L na enna? Yes, that is nothing but the self inductance. புரிஞ்சுதா? That is nothing but self inductance. அப்படினா I just wanted to know, very good. Okay, so now I just wanted to know the induced EMF. What is going to be induced EMF? It is nothing but minus d phi by dt. Now I can say minus d by dt of Li. L one the constant da, so I can go for L di by dt in the minus sign. Okay, va? So when the current changes through a coil, there will be an induced EMF produced in the same coil. Appadina, we can say, and the induced EMF will be equal to minus L di by dt. I liked your very classes, dear. Thank you so much, Adiba, right? Correct? Yes. Very good, Abdu. Very good. Hi, Varshida. Okay. So, ipo vandu, do we get 100 likes? No, still pending. I don't know what you guys are doing. Okay. So, ipo vandu, we are going to derive the L value, the self-inductance value for the solenoid. So, let us say, we know that phi is equal to Li, let it be there. First equation. Next one in the phi na guys, phi na BA cos theta. Purinjada, it will be nothing but BA cos theta. So now I am going to find what is B for the solenoid. What is B for the solenoid? Again, there are some selfish people. They don't want my happiness. Adinalata and the 7 people are not giving the like. Okay. So ipo vanda B na for the solenoid, it is coming as mu 0 NL. And area vanda, if this is the solenoid, in the radius vanda R, then I can go for pi R square cos theta. Okay, va? And in the direction of this area vector, and the direction of area vector vanda, it will be in the direction of magnetic field. Adinala, I can say that this value will be coming as 1. Till this everybody understood? Till this everybody understood? Yes or no? Please let me know in the chat box. Please let me know in the chat box. Okay, so ipo vanda I know what is the small n. Small n na enna? Total number of turns divided by L. So appadina I can just replace that equation. Yes or no? Yes or no? I can just say n is equal to NL. So can we just rewrite? Yeah, na, we have n number of turns here. So now you can replace n with small n L. So NL mu 0 NL pi. Sorry. So this is I. Sorry. I made a mistake over here. This is I. Okay. Mu 0 Ni. I have written it as L. It is I. Okay, mu 0 Ni pi R square. Purinjada, till this everybody understood? Yes or no? Flux vanda NBA cos theta. Okay, NBA cos theta. N I have rewrote it as N into L. Then mu 0, B vanda mu 0 Ni. Then we have the area, that is nothing but pi R square. Okay, now we can just rewrite. N square L mu 0 pi R square into I. Purinjada everybody? Everybody understood? N square L mu 0 I into pi R square. This is equation number 2. Now I can see that in the left hand side we have phi in the first 2 equation. Appadina, first equation will be equal to second equation. Now I can say Li will be equal to N square L mu 0 pi R square I. So ipo vanda in the I will be get cancelled and we will be getting L. If you are just studying this 60 marks, it is not possible. Okay, இப்போ வந்து we are just covering 4 chapters. How we will be getting 60 plus? It's not possible, right? Okay, va? So, sorry. So, இப்போ வந்து we got L is equal to mu 0 n square L pi r square. Okay. So, next one we are going for the mutual induction. Okay. Okay. We are going for the mutual induction. Mutual induction na, it is again easy. It is again an easy concept. Okay. Self-inductance na, very easy. Self-inductance na, same coil la current is flowing. So, in the current change பண்ணும்போது we know அது வந்து magnetic field change ஆகிறதுக்கு reason ஆகும். Magnetic field change ஆனா இந்த flux change ஆகும். கரெக்டா? Flux change ஆனா அதுல induced EMF develop ஆகும். அந்த induced EMF அந்த process தான் self-induction. Okay? That is what? Okay? There is no point in asking, ma'am, can I study this will be giving. And if you are just asking, I can just tell you 60 plus na, you should work really hard. And if you don't have much time, on the high weightage chapters you can focus. And on the high weightage chapter la, you need to study line by line. Then you will be getting the total marks. Whatever, like 50 plus marks, you can able to get it even. That is what the thing. Okay. So, இப்போ வந்து mutual induction. Mutual induction na, Varshida understood? Okay. So, இப்போ வந்து mutual induction na, one coil. Okay, we have two coils. Okay, mutual. Okay, and the name la we can understand. Okay, in the exam time la we will get to know in the mutual understanding enna. Correct? Exam time la we will be having some sort of mutual understanding. Correct? Yes or no? Let me know in the chat box. What is that mutual understanding? Huh? What is that mutual understanding? Okay, so இப்போ வந்து the same meaning da. Okay, same meaning da. இப்போ வந்து ma'am NL na இது வந்து number of turns. Number of turns na என்ன? We are taking the number of the small n in the solenoid. What we are saying, the total number of turns per unit length. Okay, wow. So we are just replacing that because we know phi which is equal to n times BA cos theta if there are n turns. Okay, so இப்போ வந்து mutual induction. Okay, so mutual induction na we have two coils. Okay, we have two coils and the two coils in the coil current is flowing. And the current flow பண்றதுனால there will be a magnetic field. And the magnetic field use பண்ணி in the coil flux change will happen, induced EMF will develop. Okay, very simple. இப்போ வந்து in the coil current is flowing. Magnetic field produce ஆகும். And the magnetic field will reach to the second coil. And the second coil due to the magnetic field from the first one, there will be a induced EMF. Appadina, I can say if I'm saying the flux change which is happening in the first coil, then I can say this will be proportional to I2. Correct? Okay. In the first coil flux change பண்றதுக்கு reason என்ன? In the second coil இருக்கிற current da. In the second coil flux change பண்றதுக்கு என்ன reason? In the first coil flow பண்றா இந்த current da. Okay, understood? புரிஞ்சுதா? Everybody, please let me know in the chat box. Everybody quickly. Please let me know. Okay, so இப்போ வந்து we are going for introducing a constant. அதுதான் வந்து our mutual inductance. Okay, mutual inductance. So phi 1 will be equal to M1 to I2. Guys, please concentrate here. Okay, please concentrate here. அதுக்கப்புறம் we can discuss because in the time we have only hardly 3.5 hours. அதுக்குள்ள I need to finish 4 chapters. I don't want to tell the answer for whatever you are asking. புரிஞ்சுதா? So just focus over here. At least the time when you are asking this, ma'am, idu padicha mattum poduma, this is enough, that is enough. And the time mattum podu, you can study one topic. Okay, I'm not going to answer for all this question. So understand, in the flux வந்து mutual inductance in the one the constant da. Okay, so in the flux change which is happening in the first coil, it is nothing but due to the current flow in the second one. Okay, இப்போ வந்து we should know the induced EMF. Induced EMF is nothing but d phi1 divided by dt. So அப்படினா we can say d by dt of m12 I2. So m12 is a constant. So we can say that minus sign will be there and di2 by dt. So இதுதான் வந்து induced EMF in the first coil. Induced EMF in the second coil வந்து m21 into di1 by dt. புரிஞ்சுதா everybody? Yes or no? Please let me know in the chat. Thank you Mithun. Thank you people. So tell me, understood this induced EMF? More energy, yes, of course, we have that, right? So இப்போ வந்து we are going for the derivation. Okay, wow. இப்போ வந்து we are going for the derivation. And also guys, if you are just focusing on the Neet previous year questions, Neet exam, we have given a very 38 years question paper. Okay, question set we have already released. So if you want, you can just check it out. In the description box, the link, everything is given. So you can just check it. Okay, understood? Let us go for it. Okay, so இப்போ வந்து we know we have to find this phi1. Phi1 na enna? We said the flux changes due to due to the flux, or let's say magnetic field in the produced in the second coil. Appadina I can say B2, correct? B2, A1, again cos will be coming as 0, then it will be 1, cos 0 will be 1, and we have the number of turns which is equal to n. So this is nothing but in the first coil. So we can say that in the phi1 will be equal to n1 A1 B2. புரிஞ்சுதா? So இப்போ வந்து I just wanted to know what is B2. B2 na enna? mu0 n2. Correct? Number of turns per unit length in the second coil into I2, because I'm representing the value for B2. And then again area. Okay, area into N1. So if I'm just going to change this small, the capital N. Yena capital N na enna? Capital N1 na enna? We know n is equal to n1 divided by L. Let us imagine length is same for both the cases. So appadina n1 L which is equal to n1. So I'm replacing this mu0 n2 I2 A1. I can just write it as pi r1 square. Then we have this n1 L. Purinjida, just we are giving the values. B2 we have substituted, N1 we have substituted, A1 we have substituted. Okay, now you can just make some rearrangement. So we will be getting mu0 N1 N2 pi R1 square L I2. Okay, wow? So இப்போ வந்து we know phi is nothing but M12 which is equal to, M12 I2 which is equal to mu0 n1 n2 pi r1 square L I2. I2 will be get cancelled, and you will be getting the m12 as mu0 n1 n2 pi r1 square L. Okay, wow? So இப்போ வந்து I can find the m21 also. That will also come as the same one, n1 m2 pi r2 square. We are imagine this radius also same. So அப்படினா we can say this thing. Okay, so m12 will be equal to m21. So இதுதான் வந்து இந்த mutual induction. So self induction is over, mutual induction is over. Purinjuda, everybody. So now let us go for AC. Alternating current, everybody ready? Everybody ready? Can we go for? Yes, solenoid. Or otherwise you can just change the small n in terms of capital N. That is what. And at the ends it will be coming as just half of the thing, because solenoid will act as a bar magnet. So inside the field will be uniform. At the end, when it comes to the end, it will reduce to half of it. Okay. If you guys ready now, give me a fire in the chat box, everybody. Everybody give me a chat fire. Eppadra. That we will cover in AC. Don't worry, Shruti. Okay, let us go for it. So now we are going for the chapter AC. So to study the most easiest chapter is nothing but AC only, alternating current. So alternating current na in the magnitude, direction, both magnitude and direction, both magnitude and direction varies with time. Okay, yes, entering to the prime chapter. Very good. Okay, so if you are representing the voltage, we can say V0 sin omega t, because this is nothing but a sine function. So we can say V is equal to V0 sin omega t, and in the V0 we will call it as peak value, the maximum value voltage. Adha in the voltage. And in the left hand side we will always represent the instantaneous voltage. Okay, we will always represent the instantaneous voltage. Yena, the reason is in the instantaneous voltage na, nothing but if I'm just checking on this complete cycle. Okay, if I'm just checking on the complete cycle, what is going to be the total voltage? What is going to be the total voltage? Yes, this and this will be get cancelled. If I'm checking on the average value for a complete cycle, it will be coming as 0. Okay, understood. So now we have a AZ. Okay, AZ a voltage graph is here. So if you are just checking for the complete cycle, in the voltage average value the 0. Okay, average value the 0. Correcta? So adinala I can only say the instantaneous values. Adinala I'm saying the instantaneous potential it is nothing but V0 sin omega t. Yes, hi, good evening Damodara, you are a little late. Okay, so in the average value we can note. So on the time in the arithmetic progression, or let's say in the mathematical, if we cannot find the if we cannot find the average value, on the time we will introduce another value, adada in the RMS value. Okay, adada in the RMS value. RMS value na root mean square velocity. Okay, it is nothing but root mean square velocity. So, root mean square voltage. Okay, so we are going to understand what is this RMS. Okay, what is this RMS value? Adakaga, we know, let us say I'm just taking a DC source. Okay, I'm taking a DC source. I'm connecting an external resistance R. I'm taking an AC source. Same I am connecting with a resistance R. Purinjada? Okay. So, I can find the voltage, current, everything in the DC's power supply. If the power supply is DC, I can find V and I. There is no problem at all. Correcta? Abadina, in the case, okay, in the case, I am giving this DC source. Now, the heat developed is, let's say, 100 joules. புரிஞ்சுதா? So in the root mean square voltage வந்து we cannot direct off, we cannot find it. Okay, அதுக்காக we are going for a very small assumption, or let's say we are going for another calculation. அது வந்து we are taking a DC source. Okay, we are taking a DC source. And the DC source we are connecting with the resistance R. So இப்போ வந்து இந்த current is flowing through the circuit. அதனால there will be some heat developed. Now I am assuming and the heat amount I got it 100 joules. புரிஞ்சுதா? அது வந்து 100 joules. அப்படினா இந்த 100 joules produce பண்றதுக்கு தேவையான current potential எல்லாம் எனக்கு இந்த DC source apply பண்றதுல இருந்து I can find it. Okay? So இந்த DC part வந்து அவ்ளோ easy தான். இப்போ வந்து what I'm going to do? I am going to give the same amount of heat in the AC source also. Okay, I cannot directly find the voltage and current here. Ana in the DC source na I can find it. Okay, so DC source na enna, we will be giving the current, and due to that there will be a heat loss, and the heat loss amount we are just imagine, or we are just taking 100 joules, or let's say some x joules. In the same way, we will heat up this also with the same amount of heat. Okay, same amount of heat. So in the time in the 100 joule heat produce பண்றதுக்காக what is the amount of I and V? அதுதான் வந்து நம்ம RMS value in case of AC. Okay, let me just repeat again. Focus here. இப்போ வந்து we have a AC source, we have a DC source. In the DC source ல இருக்கிற voltage and current வந்து to understand, it is not a big deal. We already get the value. So இப்போ வந்து using the DC source, I have increased the heat up to 100 joules. Okay, and the heat energy develop ஆன heat energy வந்து 100 joules. And இப்போ வந்து I can measure the heat in the AC source. Okay, if I am connecting an AC source and the circuit la, what is the amount of heat produced, I can understand. And now this reaches up to 100 joules, same as DC. Okay, so இப்போ வந்து we understood, we heated up both the circuit with 100 joules, and in the circuit in the DC circuit la, voltage current என்னன்னு we know it. And the voltage and the current da inge RMS value. புரிஞ்சுதா? Yes or no? Yes or no? Both. How could I say I'm not the person who is writing the answer, keep making the question paper, right? PYQs, if you are just solving the PYQs, that will be more better, you will be getting the more confidence. Confidence da sometimes we are, we are lagging in terms of this, what is a confidence? So on the confidence, okay, last year question paper I have solved simply. So on the confidence, if you can just go for PYQs, and a sample question paper also it is required. Okay, very good. So appadina I can say that here it is I0, here it is V0. Appadina VRMS. Okay, VRMS vanda V0 by root 2. IRMS, it is nothing but I0 divided by root 2. So in the values vanda you have to study. Purinjida everybody? Everybody understood? Yes or no? Yes or no? Wow, I can see a lot of hearts. I can see lots of fire. Thank you so much, guys. So, now we are going for the phasor diagram. Okay, phasor diagram. So, in the phasor diagram, we know in the potential, or let's say in the voltage and current, the scalar quantities. But we need to represent in a vector format. That's we are using the phasor diagram. Okay, so in the phasor diagram, to represent the scalar quantities like current, potential as a rotating vector, adukku we are using the phasor diagram. Purinjada. And also we can say that this will be always in the anti-clockwise direction. In the phasor diagram, always anti-clockwise direction. And you can say in the length of the, okay, the length of the vector, we can say that that is nothing but the peak value. Okay, if I am representing current like this, இதோட length தான் nothing but I0. If I am drawing a perpendicular towards y-axis, புரிஞ்சுதா? If I am drawing a perpendicular towards y-axis, that will give you the instantaneous value. Okay, so in the phasor diagram and the length வந்து, okay, the length is representing it as the peak value, and if I am drawing the shadow of this vector in the y-axis, other than nothing but instantaneous. If I wanted to know the current at this point, I can find it. I can just go for a perpendicular line. Okay, va? So this is how we will be representing a phasor diagram. Okay, va? Okay, va? Understood? Yes or no? Let us go for the resistance circuit. Let us go for it. AC connecting with a resistor, just resistance. An AC voltage supply is giving to a resistor. Yes, perfect. So now we have an AC source over here, and we have given a resistance over here, and the potential we know it is V0 sin omega t. And current order equation we know it is nothing but V by R. We got it from here. V0 sin omega t divided by R. So in the peak voltage divided by resistance வந்து peak current da, அப்படினா I can say I0 sin omega t. So இப்போ வந்து I got V is equal to V0 sin omega t, I which is equal to V0 by, or let's say I0 sin omega t. புரிஞ்சுதா கண்ணா? Everybody understood? Everybody? Yes, Mithun. Correct. Peak current. Okay. So, அப்படினா we got V and I. இப்போ வந்து I just wanted to know what is the phase difference. What is the phase difference? இப்போ வந்து if I'm just looking at the angle and the phase difference வந்து 0. So if I am representing graphically, so I'll be getting a graph like this. Okay, this is representing V, and there is no phase change. Adinala we can go for the current like this, and the magnitude வந்து கொஞ்சம் கம்மியா இருக்கும் comparing with the voltage. ஏனா in the I0 value we know V0 by R. So the value வந்து இந்த current ஓட value வந்து 1 by R times reduce ஆச்சு comparing with the voltage. So அப்படினா we can say in the graph will be coming like this. இப்போ வந்து we should know the phasor diagram. Phasor diagramத்துக்காக we are just giving the current and the voltage in the same direction. Yena there is no phase difference, magnitude la konjam difference irukum, adinala I'm just writing this is I, this is V. Okay va? This is what the phasor diagram for the resistive circuit. Okay, purinjada? Everybody got it? So idu vanda nothing but the resistive circuit. Okay. Everybody got it? Okay. So ipo vanda I'm going for the inductive circuit. Okay. Bye Darshu, bye. Okay. So ipo vanda we are going for the inductive circuit. So inductive circuit, we are giving AC supply to a inductive circuit. Hi Jenny, hi. Okay, yes. What is your name? Is something coming like this? They are in phase. There is no phase difference. Okay. So இப்போ வந்து inductive circuitல வந்து we know the potential வந்து V0 sin omega t. Correcta? V0 sin omega t. இப்போ வந்து I know that in the V will be equal to L di by dt. I'm not thinking about the minus sign, which is representing it is negative in the opposite direction. Oh, Galaxy is going. Okay, bye Galaxy. Sorry Darshu. Okay, so இப்போ வந்து L di by dt. So I'm writing V by L dt, which is equal to di. புரிஞ்சுதா? So இப்போ வந்து I wanted to get I. அப்படினா what I can do? To get I can integrate di. So I'll be integrating V by L dt. இப்போ வந்து I know what is V. V na enna? V0 sin omega t divided by L dt. constants வந்து we can take it out. Integral sin omega t dt. Okay, இப்போ வந்து you should tell me what is integral sin omega t. What is integral sin omega t? Everybody please tell me what is going to be the integral sin omega t. What is going to be that? It will be minus cos omega t. Understood? Understood? இப்போ வந்து இந்த minus cos omega t, I can write it as sin omega t minus pi by 2. Okay, this is an expression we are studying. Very good, very good, very good, perfect. Okay, so இப்போ வந்து we can just we can just rewrite. We are studying this in the trigonometry, so we can write sin omega t minus pi by 2. And also இதுல omega இருக்கு, so when we are integrating we will be getting the omega in the denominator. புரிஞ்சுதா? So இப்போ வந்து I can write V0 by L omega, and what is cos omega t? It is nothing but sin omega t minus pi by 2. So இப்போ வந்து இந்த V0 by L omega na peak voltage divided by reactance, inductive reactance. So I'll write V0 by XL sin omega t minus pi by 2. So இப்போ வந்து I can write this I which is equal to I0 into sin omega t minus pi by 2, and I0 is nothing but V0 by XL. Okay, so இப்போ வந்து you will be thinking like what is this XL? Inductive reactance. In the inductive reactance என்னன்னா, it is a very simple thing. In the when we are talking about resistance, right, in a resistive circuit, and the madri, if there is a current flow in an inductor, in the inductor vanda in the current oppose panna, or let's say there is a resistance from the inductor side, adha vanda inductive reactance. Adula difference என்னன்னா, இந்த reactanceக்கும் resistanceக்கும் இருக்கிற major difference என்னன்னா, இதுல வந்து இந்த reactanceல வந்து heat loss கிடையாது, heat loss இல்ல. And in the resistance la vanda heat loss irukum. Adha major difference in the resistance kum reactance kum irukra major ana difference na, reactance la heat loss, there is no heat loss, ana resistance la heat loss irukum. So adinala we can say this. Ipo vanda we should go for the phasor diagram. Phasor diagram paakumbodhu we know that potential will be like this. Appadina, there is a lag of pi by 2. Correcta? There will be a lag of pi by 2. Correcta? In the current vanda pi by 2 lag. So appadina, how we can just write, guys? Can you just give me? Yes, voltage leads current. Tell me how it will be. How we can draw this diagram? If I'm taking V0 here, okay, yeah, in the LCR circuit, when we are going for LCR circuit, always take reference V as in this axis, then it will be helpful for you people. Okay, va? So I can just say that in the current vanda, it will be like this. Voltage leads by pi by 2 angle. Adha vanda we are getting from this two equations. In the phase difference vanda pi by 2. So whenever you are plotting the graph also, there will be a pi by 2 difference, and the magnitude vanda it will be reduced 1 by L omega times. Now we are going for the capacitive circuit. Okay, capacitive. The AC voltage we are giving to the capacitive circuit. Appadina again, we know we will be starting with V. V is equal to V0 sin omega t. Correct? So we know that Q is equal to CV. Correct? Q is equal to CV. So if I'm going for Q by T or dQ by dt, this is what current. Appadina C vanda constant da, so I'll be going for C into d by dt of V. Purinjada? Everybody got it? In the capacitive circuit, we know Q is equal to CV. Ana we need current. Current kaga what we will do, guys? What we will do? We will go for differentiating the charge. So dQ by dt vanda will be equal to I. Appadina I can say this will be equal to C into dV by dt. then we are going for the current equation. Current will be C into d by dt of V0 sin omega t. Appadina, after differentiation, we will be getting d by dt of, C omega, we will be getting cos omega t. V0 also will be there. Okay, so V0 sin omega t, whenever we are differentiating V0 sin omega t, we will be getting V0 omega cos omega t. So appadina, I'm just rearranging this equation. Ipo vanda what we got, I is equal to C omega V0 cos omega t. So appadina, I'm just writing V0 by 1 by C omega. Again C omega will be coming on the top, just a rearrangement. Then V0 sin, sin, I can write cos omega t as omega t plus pi by 2. So appadina, I can say, here we don't want V0 then. Okay, so appadina, we can say this is nothing but the peak current sin omega t plus pi by 2, and in the 1 by C omega ta in the capacitive reactance. Okay va? Okay va? Idudha vanda namma capacitive reactance. Very good, Damodara. Very good. Hi. So we got this. Now we understood the phase difference vanda current leads by pi by 2 angle. Appadina, whenever we are drawing the circuit, idudha V. Okay, we are plotting in the x-axis. Appadina, in the current will be coming like this. Yena, it leads by pi by 2. Okay va? Purinchada? Everybody got it? Okay, understood? Yes, fine. Okay, so idudha vanda namma 3 circuit. Ipa vanda we should know the relation between the frequency and this the things which we have mentioned. Ipa vanda we know that in the L omega na enna XL. And also 1 by C omega is nothing but equal to what, guys? 1 by C omega, it is nothing but equal to XC. Ipa I just wanted to plot XL versus F graph. Okay, XL versus frequency, XC versus frequency. So appadina, how will be the graph? The first graph we need, this is nothing but second graph. So how we can plot it? Very good, Damodara, Mithun, very good. Okay, so ipa we just wanted to know L into 2 pi F, which is equal to XL. Appadina, in the two values constant da, so I can just say F is proportional to XL. Ipa in the second case, when we are checking on it, it will be coming as C into 2 pi F, which is equal to XC. Appadina, 1 by F will be equal to XC. So in the first equation, in the first case, F is proportional to XL. So appadina, XL and F graph will be linear. In the second case, XC is proportional to 1 by F. So this relation indicates the graph will be like this. So in the graph konjam important da, so you should check it on. Okay va? Purinchida? Understood, guys? Understood? Very good. Straight line for the first one. And another one is going to be the graph of Y is proportional to 1 by X. Okay, now let us go for LCR circuit in series. So ipo we have an inductor, we have a resistor, we have a capacitor, and we have given with a alternating power supply. So in this case, let us say idoda reactance XL, idoda R, and for this one it is XC. Okay va? So ipa whenever we are just going for the graph, the phasor diagram, let us say this is what V are. Okay, so we can say this is nothing but VL and this is nothing but VC. Ipa I can just redraw. Let us say, if let's say the potential across VL or let's say the potential across inductor is more comparing with the capacitor, then I can go for this is VR and this one will be coming as VL minus VC. Till this understood everybody? Till this understood everybody? Yes or no? Yes or no? Let me know in the chat box. Okay. So if I need to know the net voltage, okay, I can see this side, right? This is going to be the net value. So if I'm just rearranging this will be coming over here. So this will become VL minus VC. Appadina I can just go for the Pythagoras theorem. This is nothing but V. Appadina I can go for V square is equal to, what is V square? VR square plus VL minus VC the whole square. Now I just wanted to know what is VR, the potential across the resistance. This is the series da, so the current is the same. So I can go for IR the whole square plus, and what is VL? What is VL? I into XL the whole, I into XL into I into XZ the whole square. I can just take I outside. So what we have after that? R square plus XL minus XZ the whole square. Okay, wow. So I'm just taking I square only we are taking. If I'm taking V square by I square, okay, V square by I square, what I'll be getting? R square plus XL minus XZ the whole square. Purinjida? Understood? Yes or no? Please let me know in the chat box. Please let me know in the chat box. Till this everybody understood? Yes or no? Yes, Nitish? Got it? Okay, so now we got V square by I square. Now I'm just cancelling the square. Appadina V by I na enna? V by I na enna? It is nothing but the potential across this series circuit divided by the current which is passing through it, and the quantity we are calling it as impedance. And on the impedance it is nothing but R square plus XL minus XC the whole square. This is important. You should know the impedance equation, root of R square plus XL minus XC the whole square. Okay, so now we are going for the impedance triangle. Impedance triangle, now this is going to be R, this is going to be XL minus XZ, and this is nothing but our set. Okay, so I'm taking this angle as phi. So appadina you should tell me what is tan phi. Tan phi na enna? XL minus XZ divided by R. The direction of impedance, if it is asked, you can just go for this value. XL minus XZ divided by R. Okay. Understood? Yes or no? So next one we are going for the power. Yes, very good, very good. Okay. Power in the circuit. Okay, so let us just go for the LZR circuit. So we know V, the potential is nothing but V0 sin omega t. Current, I am taking it as I naught into sin omega t plus phi. Okay, va? So this is the equation. I'm just saying the current is having some phase difference with the potential. Thank you so much, guys. Thank you so much. Okay. Yes. Okay. So now we got the power. We know the equation for power. What is the equation for power? I into V. So appadina I'm just going for V0, I0, sin omega t and sin omega t plus phi. Okay. So now we should use a trigonometric relation. Yena inge sin A. Okay, we have this sin A into sin B. What is sin A into sin B? Let me know in the chat box. What is sin A into sin B? Everybody give me the answer. Sin A into sin B. What is going to be sin A into sin B? Sanjay irkiya. If he is there, he will definitely give reply, Vignesh. You focus here. Okay. So what is going to be that? What is going to be that? The sin A into sin B will be coming as half into cos A minus B minus cos A plus B. Okay va? Okay va? Cos A minus B in minus cos A plus B. Okay, so now in the case la vande A vande omega t, B vande omega t plus phi. So now I'm just going to apply this V0 I0 half into cos A minus omega t minus phi. So we will be getting cos of minus phi. Yena it is A minus B. A na omega t minus omega t minus phi. And next one the minus cos omega t plus omega t will coming as 2 omega t plus phi. So this is the relation. Now whenever we are taking the average value for this one, cos function, okay, if you are taking the average value of cos 2 omega t plus phi, adoda answer vanda 0. Okay, adoda answer vanda 0. அப்படினா we have only V0 I0 L by 2. புரிஞ்சுதா V0 I0 1 by 2 is going to be the value. And இப்போ வந்து cos of minus phi na, it is simply cos phi da. Okay, very good. I'm getting the answers in the chat box. Very good, Damodara Vignesh. Okay, so இப்போ வந்து இதோட answer na V0 I0 divided by 2 cos of minus phi will be cos phi only. So அப்படினா we can say V0 I0 divided by 2 into cos phi. இப்போ வந்து I'm rearranging this. P is equal to V0 by root 2 I0 by root 2 into cos phi. So idhila vanda V0 by root 2 na Vz in the beginning itself. What is that value? Vrms. This is Irms into cos phi. In the cos phi the whatever we are calling it as the power factor. Okay, in the cos phi the nothing but the power factor. Purinjida, everybody got it? Yes or no? Yes, power factor. Very good, Mithun, Damodara and Darshu. Yes, Vignesh, very good. So we got the power factor. Now we should understand there is a wattless current as well as watt current. Okay va? So this is what our power. So this is what our angle, what we have taken phi, right? Okay, phi. And now we will be having the third side over here. So if you are just checking on it, you will be getting this cos phi. Cos phi na enna? Tell me what is going to be the cos. Sorry. Okay. So we know in the cos phi now, or let's say the true power which we are experiencing, that is what Irms into Vrms into cos phi. Appadina we can say that in the cos phi the true power divided by apparent power. Okay, true power divided by apparent power. So cos phi will be coming as true power divided by apparent power. Apparent power now, what is the watt current we are getting? That is nothing but Irms into Vrms. And also there is another quantity, wattless current. Wattless current is nothing but Irms into Vrms into sin phi. So on the quantity on the Vrms Irms into sin phi we will call it as wattless current. Yena even though there is a current flow, aanalum anga there is no heat loss. Okay, so adha we are calling it as the wattless current. And when it comes to the circuit, okay, when it comes to we got to know the power which we are getting, Vrms into Irms into cos phi. So I'm just going for the resistive circuit la power. Okay, adla phase difference na enna 0. Appadina power Vrms into Irms cos 0 1. இப்போ வந்து inductive circuitல we are going to apply this. Inductive circuitல வந்து we know VRMS into IRMS into and the phase difference enna guys 90 degree. So அதனால cos 90 0. So power loss in the inductive circuit வந்து 0 and power loss in the capacitive circuit வந்து again 0. ஏன்னா அங்க கூட phase difference வந்து 90 degree தான். So the power loss is only happening with the resistive circuit. So அதனால the rest of the power which is through the inductive circuit and capacitive circuit we will be call it as wattless current. Okay va? All good, all set, everybody tell me. All set? Okay, cool. Very good. So இப்போ வந்து we have studied about the things in the LZR circuit. Now we can just go for the transformer. அதுதான் வந்து important ஆன another topic. புரிஞ்சுதா? Let us go for the transformer. Are you guys ready? Ready na? Fire போட்டுக்கோ in the chat boxல. Everybody in the chapter we have the transformer as well as the AC generator. அதுக்கப்புறம் we can go for a very short break. அதுக்கப்புறம் we can continue with the wave optics. Okay? And dual nature also. I plan to go for both. ஏன்னா wave optics ல வந்து we will be covering the major ஆன topics, important ஆன things மட்டும். Works in the principle of mutual inductance. Okay? Mutual inductance. In the atom nuclear dulla we will be covering on 19th we have a Maha Marathon. So on the day we will be covering whatever be the pending topics which are all very small topics, and the chapters we will be discussed there on that day. Rest of the chapters quick we will cover. Okay va? Cool. So இப்போ இந்த transformer works under the principle of mutual induction. Okay, in the primary coil we will be giving the current, and due to the current there will be a magnetic field will be produced, and the magnetic field lines will be passes through the secondary windings. So adanala there will be a flux change which is happening in the secondary coil. Okay, adudha in the whatever we are saying the transformer oda principle. Okay va? Yes. Okay, fine. Okay, so now what we have done, many people are still you people didn't even give me the like. Why? What is the reason? Nitish, yes, Nitish. Your name is Nitish or you are calling Nitish? Okay, so transformer la we will be having, this is how the transformer actually. Okay, so here there will be the primary windings, also the secondary windings. இப்போ we will be giving the current or let's say the voltage supply in the primary. So on the primary current flow nala we said in the electromagnetic induction chapter we have mentioned there will be some the magnetic field will be produced, and the magnetic field will be due to the magnetic field produced in the field lines will passes through the secondary coil. So on the field lines is passing through the secondary coil na there will be a flux there will be a change in flux. Adanala anga induced EMF will be produced. Appadina we have two types, step up and step down. So these are the two transformers we have. Step up na we need to increase the potential. Step down na we need to decrease the potential, and the higher potential we need to make it to lower potential. Okay Nitish, okay, done. Step up and step down. So idhula if you are just checking on the number of windings in the step up transformer okay, in the number of windings, number of turns in the step up la what will happen guys, what will happen in which in the step up transformer la what will happen in the secondary coil or primary coil. Idu primary coil and idu secondary coil, in which primary or secondary we will be having the more windings or let's say more number of turns in the step up. So in the secondary or the primary, which one will be having the more number of windings? More number of windings. Yes, of course. Yes, very good. So we know that we need to get the secondary in the secondary we need more potential than the primary. So the number of turns should be greater than the primary. Very good, guys. Very good. Super. Okay. Principle on the mutual induction. Mutual induction we have discussed in the last electromagnetic induction. You can write the principle. Okay. So, இப்போ the Vs is greater than Np. Primary coil current is passing through it. So, அப்படினா what will happen? Magnetic field produce ஆச்சு. Magnetic field produce ஆச்சுனா what we can say? Magnetic field produce ஆச்சுனா in the field lines will be used by the secondary coil. Okay, அங்க due to this field, which means the field produced by the primary, in the secondary what will happen? In the secondary what will happen? It will produce change in flux. Change in flux there will be an induced EMF. Okay, there will be a induced EMF. Okay, so இப்போ we can say the number of turns greater than number of turns in the secondary coil is greater than the primary coil, and in the current will be greater than in case of primary comparing with the secondary. இப்போ இங்க just opposite, we can just go for this. Ns will be less than that of Np and Ip will be greater than that of Is. In the relation you should know. If it is an ideal, if the power, or let's say if it is highly efficient, we can just say that the efficiency, we can say that the power we got output in the output power divided by input power. Output power in the secondary coil what we got it. So that is nothing but VSIS, and this will be coming as VPIP. Okay va? Understood? Yes or no? Yes or no? So in the things, what are the things we have written over here? You should study Vs by Vp should be equal to Ns by Np. Okay, which is supposed to be equal to Is by Ip. And the relation you should know. Okay. It is wrong. What? Is Vs, right? Which one is wrong? Dhoni, MS Dhoni. Same current, where? I didn't wrote same current anywhere. Is Vs, Vp, Ip. Where I have made a wrong one? I'm not getting. Ip and Is. Okay. Sorry. Oh, sorry, not here. Oh my God. Okay. This is correct only. Here only I made mistake. Yeah, fine. Now it's sorted. Sorry. Okay, I was also a bit confused. Okay. So now we got this relation. Okay va? So now we have the efficiency. Efficiency is nothing but the output power divided by input power. So marakama like panniko, share panniko, subscribe panniko, Telegram channel join பண்ணிக்கோ. ஏனா இது CBSE க்கு மட்டும் இல்ல, we are focusing on the NEET exam. The major core NEET தான். Okay வா? Adeline, correct? Yes. So இப்போ there are many things we should discuss. So இதுல there will be a there will be a flux leakage. Adukkaga we will be doing the lamination. Okay, so and the madri, and also sorry, for eddy currents we are doing the, it is a unwanted loss of current. So adukada we will be doing the lamination, and we will be using the core, soft core iron. Yena in the field lines one, it should be stuck. I mean, let us say this is producing more field lines in the primary, and it is not reaching, or let's say sufficient and the produce on and the field lines, total field lines one, it is not getting by the what to say, in the secondary na, there is a, I mean, there will be a lot of loss, right? So adanala da we are using the soft iron core to what to say, we need to take all the field lines to trap all the field lines. And second one in the eddy currents na, it is an unwanted one, and there will be a loss due to eddy currents. Adanala we will be doing the lamination. Okay va? So these are the things we should study in the transformer part. Next one we should know the AC generator. Okay, let us go for the AC generator. Are you guys ready? Excited? Yes or no? Yes or no? Are you guys ready? Yeah, that is what you just need to understand what is this. Okay. So ipo we are going for the AC generator. AC generator is actually working under the principle of AC generator. What is the principle? Electromagnetic induction. Okay, this is the principle. Okay, so ipo we will be having an armature coil, and we kept this armature coil in a strong polarization. Deleted. Okay, focus here please. Okay, so ipo we have the armature coil in between two strong magnetic field. So in the armature coil it will rotate in between the magnetic field. So anga uniform magnetic field irukku, in the bar magnets nala anga magnetic field irukku. So and the field, due to the field, it will experience a torque. Okay, and we can say that there will be an induced EMF when this coil is rotating. It will cut the flux lines. புரிஞ்சுதா? So இப்போ இதுதான் நம்ம armature coil. So field lines இப்படி போகும். So now it will just rotate like this. அப்படினா there will be a lots of flux change, or let's say there will be, the field lines will cut. Okay, the field lines will cut, and it will produce flux change. Now I can say that there will be a induced EMF. There will be a induced EMF, and the induced EMF will be equal to minus N d phi by dt. So ipo we should know what is this phi. Phi na enna? It is nothing but BA cos theta. So I can go for minus N d by dt of BA cos theta. So ipo we can just rewrite theta in terms of angular velocity. So appadina I am writing d by dt of BA cos omega t. Purinjada everybody? So ipo what we need to do after this? We just need to integrate this. Adukkaga we are going for minus N BA d by dt of cos omega t. Cos omega t will be coming as omega sin omega t. Okay, and what is going to be the maximum value? What is the maximum value for the induced EMF here? The peak value. What is going to be the peak value? It is nothing but when sin omega t is becoming 1. Okay, when the sin omega t will become 1? When it is perpendicular. Okay, so appadina we can say the peak value N B A omega, the voltage. Okay, so idhila you should know how to draw the diagram. Okay, you should know how to draw the diagram. Second thing is like you should write the principle. Third thing is like the working. Working is very simple. We know what is electromagnetic induction. The same thing we can just write. So here we have an armature coil. In the armature coil, we will be placing in between strong magnetic field. So in the armature coil rotate பண்ணும்போது, it will cut the field lines and it will produce the change in flux. In the change in flux will produce the induced EMF, and the induced EMF order value the whatever we have written over here. Okay va? So இதுதா we should know. So next we are going for the wave optics. அதுக்கு முன்னாடி we can just take, right now the timing is 6:50. So we can just resume at 7. Okay, sharp 7. Everybody should be here. Okay, so then we can just start the wave optics chapter. புரிஞ்சுதா? All good? I mean, nobody should sit with the mobile phone. You guys should take a proper break and you should walk around, drink plenty of water and take a bottle of water and come, make all the notes and just go through it. Then we can again go for ray optics. Bye guys. Hello, hello, hello. Are you guys there? Hello. Yes, yes, yes. Hi, 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 hi. Okay, everybody had a good refreshment. Everyone walk around and you done something apart from scrolling on the mobile phone. Okay. Yes, 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 yes. Perfect. So I want more fire. Only Kallus is giving some sort of fires. Others, where are you guys? Yes, Damodara. Yes, yes, yes. More likes. More likes. I want more likes. Sorry, sorry, sorry. Okay. Yes. Perfect. Okay. So, we have studied about AC, and in AC we missed one more topic, that is about the resonance. Okay. Resonance na inna when XL is equal to XZ. Okay. When XL is equal to XZ. We can say that what is XL, L omega, and what is XZ, 1 by C omega. So L into 2 pi F, which is equal to 1 by C into 2 pi F. So we can say that L into 4 pi square F square, which is equal to 1 by C. So F square will be coming as 1 by L C 4 pi square. Appadina we can say F is equal to 1 by 2 pi root LC. This is nothing but the resonant frequency. In the resonant frequency la, we will be getting the what is the frequency as 1 by 2 pi root LC. No, Gautam, no. We are going to cover 2 more chapters. That's it. Okay. So, இதுதான் வந்து resonance frequency கூட important தான், அந்த diagram கூட important தான். Okay. So, resonance frequency ல இந்த impedance வந்து minimum value. Impedance வந்து resonance frequency ல impedance வந்து minimum. ஏனா impedance ஓட equation na root of r square plus xl minus xz. If xl and xz are same, we will be getting z is equal to r. So, it will become a minimum value for the what to say our impedance. So resonance frequency la in the impedance vanda it is going to be very less, adanal current vanda it is going to be more. So on the resonance graph vanda you can study. So it will be like this. I forgot to paste over here. Okay, so idudha vanda the peak value current and idudha vanda namma angular frequency. Okay, so this also required for the resonant frequency. Now we are going for the wave optics. Okay va? In the wave optics, first we have to understand the wave fronts. Wave fronts, definitely, let us say we have a lake in front of us and we are throwing a stone into it. So definitely what will happen? There will be, we can see some circular kind of what to say, the wave fronts, or let's say we can see the waves basically, correct? So I'm just taking few points which is having the same vibration, or let's say which are on the same phase. Okay va? No ray optics we have just taken in the Friday session. You can watch it because detail we have explained over there. Okay va? So in the wave friends it is the collection of all the points where the points are in the same phase. Let us say I'm just saying this is how the waves are. Okay, this is how the waves are. So இப்போ வந்து I can say that this is a wave front. ஏன்னா அது வந்து two of those particles were in the same phase. And I can also say this 2 points were wave fronts. ஏன்னா அது வந்து same phase ல இருக்கு. இது 2 வந்து same phase ல இருக்கு. So இப்போ வந்து இந்த I mean the collection of points where they have where they are in the same vibration, or let's say in the same phase, then we can call it as wave fronts. Okay, yes, locus of points that oscillate in the same phase. Okay, புரிஞ்சுதா? So அதுதான் வந்து wave front. So wave front na அது வந்து 3 dimension தான். So அதுக்காக we have 3 types of wave fronts. Spherical இருக்கு, cylindrical இருக்கு, and also plane wave fronts இருக்கு. இந்த spherical wave front na, let us say we have a point source. அந்த point source ல இருந்தா இருக்கிற அந்த I mean this is how the point source is. So if this is the point source, I can just take the collection of points where it will be having the same phase. Okay, where it will be having the same phase, அப்படினா that is going to be spherical. இப்போ வந்து like our tube light na we can say that is linear na அதோட அந்த type cylindric I mean the wave front we will be call it as cylindrical wave front. இப்போ வந்து நம்ம source வந்து whether it is point, linear, whatever it may be, அது வந்து infinity னா okay, it was in infinity. அப்படினா அந்த source produce பண்ணா wave fronts வந்து it will be plane wave front. ஏனா you just imagine we have a balloon. Okay va, we have a balloon. In the balloon la we are just keeping an ant on the balloon. So for that a particular ant, அதுக்கு வந்து அந்த balloon na flat surface தான். ஆனா we know this is a round surface. So அந்த மாதிரி we can say that even let us say the sun is at infinity, correct? And the wave fronts வந்து spherical. ஆனா when it comes to us, it will be almost a plane wave. So we can say that the plane wave front is nothing but it is nothing but our plane wave front na, it is nothing but our what is a plane wave front na, it is simply we can say due to the source in infinity. புரிஞ்சுதா? Yes or no? Next one we are going for the Huygens principle, wave theory. Okay, so இப்போ வந்து Huygens wave theory, why it is more important na, because people have thought like the light is having particle nature. Light is traveling as a ray. அந்த மாதிரி தான் everybody was thinking about it. It is having only the particle nature. அந்த டைம்ல இந்த Huygens தான் introduce இந்த லைட்டுக்கு வந்து wave properties இருக்கு. இந்த interference, diffraction இதெல்லாம் வந்து லைட்டோட வேவோட ப்ராப்பர்ட்டி தான். அப்படினா definitely we will be having he is proving something. So அதுக்காக he made some theory. Okay, he made some theory. அந்த theory தான் we are going to study now. Okay வா? So அதுல வந்து definitely let us say we have the primary wave front. Okay, we have the primary wave front. In the primary wave front la each and every point will act as a point source. புரிஞ்சுதா? Okay, so let us say I have a point source over here. இதுல வந்து there are lots of wavelets produced. Okay, அதுல வந்து I took the collection of points where it is having the same constant, same phase. Okay, the particle which is vibrating in the same phase, I took a collection of it. அதுதான் வந்து என் primary wave front. இப்போ இந்த primary wave front ல each and every point வந்து what it will do guys? Yes, it will act as a secondary source. Okay, each and every point, and it will produce the secondary wavelets. All the points will produce the secondary wavelets. Okay, so each point in the primary wavefront will become the source for the secondary wavelets. Very good, perfect. Okay, understood? So இப்போ வந்து we got to know there is the secondary wavelets. In the secondary wavelets oda speed enna guys? In the secondary wavelets oda speed enna? It is same as the primary. Okay, it is same as the primary. Secondary wavelets oda speed vandu same as the primary. Now what I'm going to do? I'm going to do one thing. I'm going to draw the tangents for each of this case. Okay, I'm going to draw the tangent. And if I'm just checking on the tangent, okay, the tangent is giving me a secondary wavefront. Purinjida? The tangent is giving me a secondary wavefront. Okay, va? Okay, va? So, I can just find after some time t, what is the position of the secondary wavefront. Okay, that I can find. Okay, so in the tangent of this secondary wavelets will give me the secondary wavefront. So, this is high-G wave theory. In the detail note you will be getting after the PDF. I'm not writing. It is there in the thing itself. Okay, next one, we should know the amplitude and intensity. Okay, first one, we should know the intensity of a wave is proportional to a square. Purinjida everybody? Intensity is proportional to a square. Okay, so we should know this amplitude. Let us say if I'm having two waves which is having an amplitude A1 and A2, அப்படினா அந்த resultant amplitude வந்து A1 square plus A2 square plus 2A1 A2 cos theta. Theta is the angle between the two amplitudes A1 and A2. Okay, okay. இப்போ வந்து we have the intensity. Intensity na enna agum? I1 plus I2 plus 2 into root of I1 I2 cos theta. So you should know this equation. Yena in the equations we are studying in the chapter waves, class 11. Okay, I'm not going for all those things. Precise, I'm going to complete this chapter. Okay, va? Purinjida? Everybody understood? Understood? Yes or no? Give me the likes, please, because I'm not getting the likes. It's same as like when I was just going before the break. Okay. So, we should go for the interference. Okay. Interference, na, this will be happening. This will be happening only for the waves. Adanalatha in the interference, in the Young's double slit experiment, ivlo important. Okay, why it is becoming important? Yena, this is showing the wave property. Okay, va? Interference na very simple. We have two waves. Adu vandu superimpose, which means they both come together. So, we can just say that if they are coming together and the amplitude becomes maximum, then I will be call it as constructive interference. Okay, we will call it as constructive interference. Constructive interference na enna? In the two amplitudes, two waves combined or let's say superimpose and we are getting the maximum amplitude, then we will be call it as constructive interference. Okay, so let us say for example, idudha vandu number two waves. இப்போ this is A1, this is A2, the amplitude A1 and A2. அப்படினா, after superimposing these two waves, I will be getting the amplitude as A1 plus A2. புரிஞ்சுதா? Everybody got it? இப்போ I just wanted to go for destructive interference. Okay, I wanted to go for destructive interference. So, what is going to be destructive interference? Can you just give me the answer in the chat box? What is going to be destructive interference? What is going to be destructive interference? Constructive interference, na, two waves will superimpose and it will be giving the maximum amplitude. Apo, what is going to be destructive interference? It will be minimum. Okay, if the amplitude becomes minimum, then we will say it is nothing but, let us say, number wave one is like this is having A1, another one is like this is having A2. Appadina, the interference pattern, if let's say which one is higher one, so we will be getting like this in the this one will be A1 minus A2. Next one, we should know what is a coherent source, because in the chapter we are dealing with the coherent source. Okay, coherent source na enna? Coherent source. Okay, coherent source na very simple. Okay, coherent source na very simple. It is very easy thing. Coherent source is nothing but when we are taking, or I mean this is happening only with one, I mean only one light can be, or let's say one source can be only the coherent. If I'm taking one bulb, another bulb which is same power, whatever it may be, but it cannot be coherent. Okay, coherent na, it should have the same amplitude, it should have the same frequency, it should have the same phase difference, or let's say it should have the constant phase difference. Appadina I will call it as coherent source. Same frequency, same wavelength, and same phase difference, or let's say constant phase difference. Okay, so it is something like coherent na, I can just simply say, let us say we are singing a song. Okay, if there is a lagging, everyone should lag. Purinjida? So and the madrida in the coherent source. Okay, and it will be always from one source only can be coherent. Okay, if I'm taking two such independent sources, it cannot be, it will be never be coherent sources. Purinjida everybody. It can be only single source. Multiple source cannot produce coherent source. Okay, only one. If I'm just taking Young's double slit experiment, when we are going for Young's double slit experiment, you will understand. Okay, let us go for the next. Are you guys ready? Yes or no? Yes or no? Next one we should know. What is the path difference. Ipa I have a source over here, S1. I have another source over here, S2, and they are superimposing at the point P. So this is the thing, 1, 2, 3, 4. Almost 4, I guess. Okay, how much it is? 1, 2, 3, 4. Let us make this P over here. Okay, so here is the P. Okay, so in the path length vanda 1 cycle 1 lambda, this is 2, this is 3, and this is 4. Okay, so this is what is a path length of first one, 4 lambda. Path length we will always say in terms of lambda. Ipa vanda I have another one, 1, 2, 3, 4, 5, 6, 7. Okay, so we have 7 such lambdas. So the path length one the 7 lambda. Appadina in the path difference is very simple. Delta x will be coming as 7 lambda divided by 4 lambda, which will be coming as 3 lambda. Okay, the class will end by 8. Okay, 8 or 8:50. Oh, hi Gavrija, how are you? Okay, so Ipavanda we understood the path difference. Ipavanda we should know the path difference and the phase difference relation. So phase difference delta phi will be equal to 2 pi by lambda into delta x. In the relation you should study, we are studying this relation from the chapter waves. Okay, in the wave optics major ana portion one the waves. Okay, waves, if you know waves, this chapter is going to be easy for you. Okay. Okay, understood Gavrija, understood. Okay. So in the relation you should understand. Okay, va? Purinjida. So Ipavanda, can we go for the Young's double slit experiment? Can we go for the Young's double slit experiment? So we forgot to do this proof. Okay, let us go for this proof. This is also important. This is mentioned in the syllabus. Okay, so Ipavanta, first we have to prove, in the light we are just considering it as ray. அப்படினா definitely there will be laws of reflection. So laws of reflection na incident angle should be equal to reflected angle. So the same we should prove here as well. I will just give you the steps. So ipo vanda idhaan vanda namma wave front. Okay, idhaan vanda namma wave front. A B tha wave front. So after you can just see that in the wave front vanda it is hitting on the surface, correct? So in the point is hitting first and B is hitting after some time. So after hitting, A will travel first and this B will be reaching at this point. Purinjida? So first vanda in the A vanda it will touches the surface. So it will go for the reflection first. Okay, it will go for the reflection. And the part vanda reflection, it will be happening first. So அப்படினா I know this is the incident angle. This is the incident angle. Correct? It is nothing but the incident angle. So இப்போ வந்து I'm going to consider two triangles AEC and triangle AEC and triangle ABC. So we have two triangles. Idhula வந்து we can say they have the common side AC. So the third side of both the triangles are same. இப்போ வந்து I can also say இது வந்து happening in the same medium. So அதனால இப்போ வந்து இந்த A வந்து it is hitting on the surface and it is having a velocity V na after T time it will reach us at E. அப்படினா அந்த distance travel பண்ண அந்த distance da AE. Same thing will happen for the B part as well. Okay, and the same time T la velocity வந்து same da because the medium is not changing. அதனால இந்த BZ கூட same da. So அப்படினா I can just say that AE will be equal to BC. AE which is equal to BC. And now if you are just checking on the angle AEC and angle ABC is 90 degree. So adanala two sides same as well as one angle is same. So these two triangles are congruent triangles. So whatever be the equal sides, whatever be the angles which is coming opposite to the equal sides, that is also going to be same. Okay, so அப்படினா we can say if this is I, okay, if this is I, definitely this angle is going to be I, then we can say I will be equal to R. So the only thing in laws of reflection, to prove laws of reflection, you should prove these two triangles are congruent triangles. And the proof mattum podum, you can just do this. Okay, adukkaga you should prove two sides are equal as well as one angle is same. So அப்படினா இந்த angle, incident angle will be equal to the reflected angle. I will be equal to R. Next one, the refraction. So in the refraction la, definitely we know that this is traveling from a rarer medium to a denser medium. So idhula vandu velocity vandu different ah irukum. So ipo vandu in the medium first la vandu velocity v1, second la vandu velocity v2. Appadina in the wave front is coming like this. Okay, so after touching on the surface, in the first part vandu it will bend towards the normal. Yena it is entering to a denser medium. Okay, so after that the distance traveled by I mean whatever be the part which is inside the wavefront order part which is inside the surface, and the velocity vandu konjam kammiya irukum. So if I am considering a time t, okay, if I am considering a time t, and the time t la travel panna in the second mediathula travel panna distance vandu it is less than that of the distance traveled by the other part of the wave front in the first medium. Yena inga velocity adhigama irukum, inga velocity kammiya da irukum. So in the second mediathula vandu velocity v2 da. So in the time t la, let us say I am giving some time t la, the distance traveled by in the denser medium it will be less comparing with the rarer medium. Okay va? So ipo vanda we understood this side is nothing but v2. This side is nothing but v2 into t, and in the side vanda v1e. And I know this angle is I, so I can just simply go for sin I. Sin I na enna opposite side divided by hypotenuse, adu vandu AC. Next one I am going for sin R. Sin R, now this is the refracted angle. I can go for V2T divided by AC. So now you can just divide this both the equation. So sin I by sin R will give you V1T divided by V2T, which is nothing but T will be get cancelled. So we will be getting sin I by sin R, which is equal to V1 by V2, which is nothing but mu2 by mu1. Okay, so this is in the proof. You can just go for the steps. Diagram is important. If the question is asked, diagram you should know. You should know how to draw the diagram also. Very good, perfect. So interference, we have mentioned about the maximum intensity. Now we will say the constructive interference. Minimum intensity, now we will say destructive interference. So we have this Young's double slit experiment. As I said, we need coherent sources. And we said if we are choosing two different sources, na, adu vandu coherent agamate. Okay, adu vandu coherent agiradhukku chance illa. Okay, adu vandu coherent agiradhukku chance illa. Appadina, what will happen, guys? What will happen? Tell me, what will happen? Ipo vandu we understood the two coherent sources, or let's say two independent sources, we cannot introduce. Adinale, we can just go for only one source. Okay, I'm just passing that light through a single slit first. I mean, purinjiko, first one to get coherent source. Yeah, in the chapter, whatever we are saying, it's supposed to be coherent source. So, on the coherent source, what we are doing first, we are giving a light and it passes through a single slit. Adikapram, we have two such slits. And now what will happen? In the single slit we have the wave fronts. So in the wave fronts split agum when it reaches to the slits. So appadida we are creating the coherent sources. Okay? Now in the coherent source is passing through the slits. So when it is passing through the slits, we kept a screen over here. Interference nala, what is happening, guys? What is happening? There is bright and dark fringes is coming in the screen. Okay, alternative dark and bright branches or bright bands are forming in the screen. Okay, so in the bright band order region the constructive interference, dark band order region the destructive interference. This is the property of a wave. Adanala he has proved this light is having interference property. Adanala light particle nature mattu illa, adukku wave nature kuda irukku. Okay, so in the diagram important so you should go for the diagram. If straight you can go for the constructive interference order condition, and the path difference supposed to be 2 and 5, and the phase difference must be 2 and 5, and the path difference must be the n lambda. Okay, I'll come to it. Okay, so if we have the path difference, and the path difference the n lambda. N can be 0, 1, 2, 3. Okay, if you're putting n as 0, that's the bright and the central bright band it is indicating. If I'm going for destructive interference na, and the phase difference supposed to be the odd multiple of pi, and path difference must be the odd multiple of pi by 2, not pi by 2, lambda by 2. Okay, lambda by 2. This is the phase and path difference. In the conditions romba important you should study. Okay, va? Purinchida, everybody? And when I'm just checking on the intensity pattern, okay, if I'm going for, we got the alternative bright and dark bands. So adoda if you are just going for the intensity, okay, if you're going for the intensity, na, what we will be getting, and the intensity it is same for each cases. This is the intensity graph. Each bright and dark band we will be getting the same what is the intensity. This is in the interference we should study, in the condition we should study. Okay, So, now we should know the fringe width or let's say band width. Both one the same. In the fringe width, what is the difference? What is the distance between two consecutive, the bright or this dark branches? Okay, va? So we can say the distance between the centers of two consecutive bright or dark fringes is called the fringe width. Okay, va? So that angular fringe width, we can just go for lambda by d. Adu kuda you can just study, and the equation also you can study along with the equations. Whatever be the equations you have studied, you can go for that as well. Everybody is ready? Everybody is ready? The conditions one the important da, and also as I mentioned in the fringe width kuda important da. Okay, and in the fringe width expression the lambda d by d. Lambda the wavelength, d na the distance between screen and the slit, and d na the slit, the distance between the slits, or the distance of separation between the slit. Okay, so now the thing is like, we understood, here we are getting the bright, then the dark, again we have the bright, again we are getting the dark. So here also we are getting the consecutive, the dark and the bright fringes. Now this is the central point, okay, where we will be getting the bright fringe. So if I am taking any point, okay, any point, and the distance I will call it as xn. From the center, I will take the distance nothing but xn. Okay, va? Okay, va? So now we got xn, and the xn oda expression n into d lambda divided by d. This is for the bright band, and for the dark band, from the center, it will be coming as 2n minus 1 d lambda divided by 2d, which means whatever we have studied in the, because we can just go for this xn, xn as the 2n minus 1 d lambda divided by 2d, which is related to the equation which we have mentioned before in the path difference. So next one, the diffraction. Okay, so again diffraction in let us say we have a single slit. Okay, we have a single slit, and here we have a screen. Now we are giving a light. Okay, we are giving a light source. Okay, so we should, if it is a particle nature, it should travel in a straight line. So we are supposed to get it like this, correct? We should supposed to get it like this. Ana in the real life we cannot find it like this, correct? So the light will spread over the area. The light will spread over the area. So when there is an obstacle, when there is a corner, the light will bend. And the process the diffraction. And the only one condition, size of the slit, or let's say the aperture, okay, or let's say the obstacle, should be compared with the wavelength of the light. This is the diffraction oda condition. The diffraction depends upon two things only. First one the size of the aperture. Second one the wavelength of the light. Purinjida marakama like panniko, share panniko, and subscribe panniko. Okay va? Okay va everybody? Everybody is ready? Everybody is ready? Okay, so you will be getting the diffraction like this. So diffraction it is nothing but the bending of light or spreading of light when there is an obstacle, or let's say there is a corner. Okay, wow. So next one, we have a single source. Okay, we have a single source. Apadina, we have a single slit. So in the plane wavefronts are coming, and what will happen? According to Huygens principle, what is happening? The wavefront here, each and every point in the wavefront will act as a secondary wavelet. Correct? It will act as a secondary wavelet. Each and every point in the primary wavefront will act as a secondary wavelet. So, இப்போ வந்து இந்த wavefront is reached here. அப்படினா each and every point, okay, each and every point will act as a secondary source or secondary wavelets. அப்படினா definitely each and every point will be producing the secondary wavelengths, okay, and it will superimpose at some point. Okay, so this will be happening at different positions, and when I'm checking on the central position, okay, when I'm checking on the central position, I can see that the maximum, okay, the intensity is maximum, okay, intensity is maximum. The path difference one in the case la 0, the path difference one the it was coming as 0 in the case of central maxima, and adoda intensity one the adhigama irukku yena all the lights are coming and superimpose here. When it comes to any other point, what is happening? Each and every wavelet is having another one which is in the other end, and it will cancel each other, and we will be getting the lesser intensity. All the wavefronts, all the secondary wavelets are not contributing to the rest of the cases. Okay, so இப்போ வந்து you should understand each and every point in the wavefront will act as a secondary source, and they will be producing the secondary wavelets, and it will be creating the maximum intensity at the center. And when it comes to up or down, what will happen? The contribution, all the secondary wavelets are not contributing to that point, so adinala in the intensity வந்து reduce ஆகும். Okay, or not all the points are giving the what is it, contributing to it, so adinala it won't be coming as the same intensity as the central maximum. And we can say that whatever be the okay, we can just come to it. Before that in the derivation one it is not in the syllabus, adinala you should study some of the equations directly. So adula vandu first one vandu I'm just drawing a perpendicular, okay, I'm just drawing a perpendicular. In the perpendicular will give me the path difference between these 2 points. Okay, so இப்போ வந்து this is a secondary wavelet, இது வந்து another wavelet, so the two will be having a difference, the length la வந்து difference இருக்கு, அந்த path difference we need to find. Okay va, so adukkaga first thing I can do, the path difference S2Q will be coming as, if this angle is theta, I can go for this angle also theta, adanala it will be coming as A sin theta. Okay va, A sin theta purinjudha. So ipo vandu we are drawing a perpendicular towards this line. Okay, we are drawing a perpendicular towards that line, and this angle is theta. Appadina this will be coming as A sin theta. Adudha vandu nothing but our what is the path difference. Idu vandu S1 da. Okay, I'm taking this as S2. Appadina S2Q vandu A sin theta. This you should understand. How we are getting and all these things you can just completely skip. Adu vandu it is not that much important. Okay, so இப்போ வந்து I'm going to find tan theta. இப்போ வந்து we know this angle is theta, correct? So you should tell me what is tan theta. So இது வந்து xn, and the distance between slit and the screen is d. அப்படினா tan theta na xn divided by d. Okay, xn divided by d. So we got tan theta which is equal to xn divided by d. Appadina in the small angle approximation la I can say that in the path difference delta x vandu A theta. Okay, and here theta will be coming as xn divided by d. Purinjudha? xn will be coming as the what? What is xn? Xn is coming as, we can say, d into theta. Okay, so xn will be coming as From this we can just write xn is coming as d theta. Now we should know the condition for minima and maxima in this case. Okay, so when we are talking about diffraction, we understood the intensity pattern it will be maximum at the center, then coming to up and down it will reduce and the secondary wavelets complete contribute pannala. And now we made few relation a theta which is equal to the path difference, and also we have studied xn is nothing but d theta. So now I'm just writing for the condition for minima. Minima in the path difference must be n lambda. So you guys need to study the only the conditions only. So now we know n lambda we already found in this case. It is nothing but a theta. So I'm substituting a theta. So then I can go for n lambda divided by a, which is equal to theta. Appadina xn, what was xn? What we got it as xn? Xn is nothing but d theta. So appadina I'm going for d into what is theta? N lambda divided by a. So இதுதான் in the minima oda condition na delta x must be n lambda, and we are substituting n lambda is equal to a theta, and we are finding theta, then we will be substituting in the xn. So you can just find the distance from the central maxima to the point, any point we can find if you know n, if you know the distance between the screen, if you know the lambda, and also the slit width. In the a it is nothing but the slit width in this case. Purinjada? And n can be plus or minus 1, plus or minus 2, plus or minus 3, like that way it will go. Okay. Now yes, Gopalakrishnan, good evening. So now we should know minima condition we have studied, and if you are just comparing with the interference, anga n lambda na maxima oda condition. So you can just compare and you can study. Otherwise, to study all those things it will take a lot of time. So adanale anga n lambda maxima, diffraction la n lambda representing minima. Now I wanted to know the maxima, not the central maxima, and the second maxima only I wanted to find. Okay, and the second maxima only I wanted to find. Adukkaga in the path difference 2n plus 1 into lambda by 2, which means the odd multiple of lambda by 2 da idoda maxima oda condition. Okay va? So appadina S2Q na a theta, which is equal to 2n plus 1 lambda by 2. So in the interference la in the path difference for minima 2n minus 1 lambda by 2, inga it will be 2n plus 1 lambda by 2. So appadina I will be getting a theta. Next we should find theta. Theta will be coming as 2n plus 1 lambda by 2. Okay, lambda by 2a. If I wanted to find xn na d theta, so d into 2n plus 1 lambda divided by 2a. This is xn. If you are putting 1, 2, 3, you will be getting the values for xn in this case as well. Purinjada? Now we can just put n is equal to 1. What will happen if I am putting n is equal to 1? N is equal to 1 na, it will be coming as d into 2 plus 1 lambda by 2a. So appadina we will be getting d 3 lambda. We can just rearrange. Okay, we will be getting 3 d lambda divided by 2a. So this is how it will be coming. Purinjada, everybody. And in the case in the beta, in the fringe width beta 2 lambda d by a. Okay, in the case the slit width a da. So we will be getting lambda d by a. Now I just wanted to know the fringe width of the central maxima, and the central maxima it will be nothing but 2 times the first one. 2 times the fringe width of the first one. So these are the things you should study. You should study the most important conditions and everything. So everyone should study this. There is no possibility to skip anything from whatever I have taught you right now. All the graphs, all the intensity graphs, everything is mandatory. You should go through it. Okay va? So இப்போ வந்து quick we are going for the dual nature of matter and radiation. இதுல வந்து I'm just briefing it so you can just understand it easily. So in the dual nature la வந்து we were discussing about the electron emission. In the electron emission kaga 3 types we are studying. First one is thermionic, second one is field emission, third one is nothing but photoelectric effect. Thermionic emission na we are giving heat energy, and in the metal surface electrons it will get energy and it will escape. Okay va? Next one we are talking about the field emission, strong field. We will be providing strong field, and the strong field inala what will happen? The electrons will escape. Okay va? Next one the photoelectric effect. Photoelectric effect what we need. Okay, photoelectric effect idudha vandu the major topic. So idhula vandu first we should understand what is this photoelectric effect. Okay, photoelectric effect na very simple. When light is falling with a suitable frequency, light is falling with a suitable frequency, then the electrons will be getting the sufficient energy to escape from the metal surface. So by using light, by using a suitable frequency light, we can excite, or let's say we can go for the emission of electrons, and the process whatever we are calling photoelectric effect. In the photoelectric effect, first you should know what is this photon. Okay, photon na in the light particle nature. Okay, light vandu particle nature irukku. So if the light is interacting with a particle, and the light ku vandu particle property irukadum, correct? So if a light is interacting with a particle, and the light vandu it should have a particle nature, and the particle nature da photons, and the photon oda energy vandu h𝛎. Okay, இதுக்கு எனர்ஜி இருக்கு, மொமெண்டம் இருக்கு. ஓகே, இதுக்கு எனர்ஜி இருக்கு, மொமெண்டம் இருக்கு. and இதோட எனர்ஜினா இது வந்து கைனடிக் எனர்ஜி, பொட்டென்ஷியல் எனர்ஜி அந்த மாதிரி எதுவும் எனர்ஜி இல்லை. இதோட எனர்ஜினா அதோட இன்டர்னல் எனர்ஜி தான். and in the photon வந்து always travel with the speed of light. Okay, அதனால வந்து we cannot just hold the photon and we can't measure the mass. Rest mass வந்து we are considering it as 0, approximately 0. ஆனா வந்து we cannot directly find out the mass of the photon. Energy வந்து we got it h𝛎, and the velocity வந்து same as the speed of light. Okay va? And energy na that is nothing but the internal energy, kinetic energy, and that is not having any kind of relation with the photon energy. Purinjida? Mass is not defined. It is having a momentum and energy. Purinjida? So those who are not liked till now, don't forget to like, also share with your friends, subscribe the channel. Okay va? Okay, fine. So இப்போ வந்து photoelectric effect காக we should have a experimental setup. So அதில் what we have a vacuum tube. Okay, we have a vacuum tube. Okay, அதில் வந்து we have a cathode as well as an anode. It is connected with the battery. Okay, it is connected with the battery. So இப்போ வந்து what will happen? The light will travel and it will fall on this metal plate. Okay va? In the light வந்து it will travel on the metal plate. So அப்போ வந்து what will happen? One second guys, I'll just come in a minute. Okay, just give me a minute. I'll just come. Just a minute is enough. Okay. Sorry guys, sorry. So let us continue. Okay, so இப்போ வந்து we are discussing about the photoelectric effect. Okay, அதில் வந்து we have a vacuum tube. Okay, we don't want any sort of ions or anything. அதனால தான் we are using the vacuum tube. அதில் வந்து we will be having a cathode and anode, or otherwise we can just say that we have a emitter plate and a collector plate. So இது வந்து we can just call it as emitter plate. Okay, emitter plate. இது வந்து collector plate. Okay, collector plate. So இப்போ வந்து இந்த light will be falling on this metal surface. As I mentioned, இந்த photonோட energy-na என்ன h𝛎. Okay, so இப்போ வந்து இந்த electron to escape from the metal surface, அதுக்கு வந்து ஒரு minimum energy வேணும். அந்த energy தான் work function. Work function என்ன? The minimum energy required for an electron to escape from the metal surface is known as the work function. We will be represent it as h𝛎0. Okay, so இப்போ வந்து the light is coming with an energy more than h𝛎0, then definitely the emission will happen. If it is less than h𝛎0, then there is no possibility of emission. ஏன்னா அந்த எலக்ட்ரானுக்கு escape ஆகிறதுக்கு it needs more energy. அதுக்கு வந்து more than this energy required. அதனால வந்து அந்த emission is not possible. புரிஞ்சுதா? So the emission is not possible. So இப்போ வந்து let us say the light with suitable frequency, which means energy is more than h𝛎. So I can just say that the energy of the photon is h𝛎, and then I can say that it will be used for h𝛎0 to escape from the surface, and there will be some additional energy is there, and the energy is used for traveling from this emitter plate to the collector plate. So adanaala I can say that energy is nothing but the kinetic energy, which is equal to half mv square. Okay, so இப்போ வந்து I'm talking about the intensity. So intensity, when I'm talking about the intensity na, it is having more brightness. If I'm saying intensity is more na, it is having more brightness. அப்படினா I can say that the number of photons, okay, brightness na, number of photons will increase. Number of photons will increase. If intensity is more, number of photons will more. And one photon will interact with only one electron. One photonukku one electron mattum da irukku. புரிஞ்சுதா? One photonukku one electron. அப்போ வந்து if I'm just talking about more number of photons na, more number of electrons will be ejected. Correct? If I'm saying intensity is more, as I mentioned, number of photons is more. If the number of photons is more na, number of electrons ejected is more. அப்படினா in the current flow will increase. புரிஞ்சுதா? current flow வந்து increase ஆகும். ஏன்னா more number of charges flow. And in the process இல்ல, இது வந்து photoelectric effect நால I will call the current as photo current. இப்போ வந்து I'm just talking about the Einstein's relation h𝛎. The total energy of one photon is h𝛎. அது வந்து it will interact with one electron. அந்த one electronக்கு தேவையான எனர்ஜினா work function h𝛎0. அந்த h𝛎0க்கு அப்புறம் whatever be the energy it has, it will travel from the emitter plate to the collector plate. ஏன்னா அதுக்கு வேற வழியே இல்லை. It will travel from the emitter to the collector plate. Okay, so அப்படினா I can just say h𝛎 is equal to h𝛎0 plus half mv square. Okay, so இப்போ வந்து what I'm going to do, I'm going to change the polarity. இப்போ வந்து I'm just giving the emitter plate as the positive charge and the collector plate as the negative charge. Using a commutator, we will be doing this. அப்படினா what will happen? I mean the electrons, even the electrons from the emitter plate, inga emitter plate irukku, inga collector plate irukku. Ana what is happening? The photon will hit and the electron will try to come. Ana vandu again there is a negative potential there. So அப்படினா even if it is having extra kinetic energy, it will try to come. Ana vandu in the negative potential will oppose the motion. Okay, it will oppose the motion. அப்படினா I can say that இந்த kinetic energy வந்து கம்ப்ளீட்டா potential energy convert ஆகும். Correct? And also at some point என்ன ஆகும் in the in the electron வந்து it is coming from here and it is trying to go to the collector plate. ஆனா இந்த motion வந்து stop ஆச்சு because of the potential, because of the higher potential. So அந்த potential, when the photo current becomes zero, and the corresponding potential we are calling it as stopping potential. And in the stopping potential வந்து it is very, very, very important, and you should know when the energy is more. Okay, energy is more. இப்போ வந்து I am going to give you 3 units of energy. Work function வந்து 1 unit தான். So இந்த electron வந்து 1 unit use பண்ணி அதுக்கப்புறம் it should use the 2 units of energy to travel. Okay, so அப்படினா இந்த stopping potential should also equal to this 2 units. Correct? இப்போ வந்து I am giving the photon ஓட energy வந்து 5 units. Again இந்த electron ஓட required ஆன work function வந்து 1 unit. அப்படினா what will happen? இந்த 5 unit energy வந்து இந்த electron will take 1 unit, and the 4 units of energy இருக்கு. ஆனா what will happen? இந்த stopping potential should increase to stop this electron. அப்படினா when energy increases na, what is the meaning? Energy is equal to h mu da, h வந்து constant da, so energy increases, which means mu increases na, definitely in the stopping potential also should increase, otherwise whatever we said, it is not going to be correct. Purinjada everybody? Yes or no? Tell me in the chat box. Tell me in the chat box, everybody. Okay? Yes, stopping potential will also increase. இப்போ வந்து இந்த relation h mu is equal to h mu naught plus half mv square. I'm going to replace it as h mu is equal to h mu naught plus evs. Okay, ஏன்னா அந்த kinetic energy வந்து potential energy convert ஆச்சு. Charge, electron charge வந்து E, stopping potential வந்து Vs. அப்படினா இந்த maximum kinetic energy வந்து it is nothing but EVs. Okay வா? புரிஞ்சுதா? இப்போ வந்து I'm just going to do one thing. Okay, I'm going to do one thing. I'm going to plot Vs versus frequency. Stopping potential and frequency oda graph tha enakku vedum. So அப்படினா I just wanted to keep this Vs only this side, right? So adukkaga I know h mu minus h mu naught will be coming as EVs. Next one I'm going to divide h by E into mu minus h by E into mu naught, which is equal to Vs. So அப்படினா I'm just comparing with the y is equal to mx plus c equation. So இதுல வந்து this quantity is completely constant. This is c. Okay, h is constant, e is constant, and this the threshold frequency for the electron also going to be fixed. Correct? So அப்படினா we can say h mu by e minus this threshold frequency, work function divided by E, which is equal to Vs. Stopping potential na, when the current, okay, the potential at which the current becomes zero, the photo current becomes zero. Okay, அதுதான் வந்து நம்ம stopping potential. So இப்போ வந்து I'm just going to compare, then I will be getting the slope வந்து h by E mu, and the c value வந்து h by E mu naught, and y-axis வந்து we will be getting it. So in the graph வந்து, if I am plotting Vs versus mu graph, I will be getting the graph like this. And in the slope வந்து h by E mu is going to be the slope. Okay வா? புரிஞ்சுதா? Okay, yes or no? Yes or no? Okay, let me know in the chat box. We are almost at the end. Okay, Damodaran, okay, MS Dhoni, very good, very good, very good. So, இப்போ வந்து we are going to discuss in the graph வந்து இந்த saturation current na almost all the electrons has been reached at the collector plate. Okay, almost all the electrons were reached. So, அதுக்கப்புறம் current இல்ல, அது வந்து saturation current, and how it is affecting and the graphs வந்து ரொம்ப important தான். Okay, so அந்த graphல stopping potential change ஆகணும்னா அதுக்கு வந்து ஒரே ஒரு reason தான் இந்த frequency வந்து increase ஆகணும் or decrease ஆகணும். Next வந்து we have the saturation current. Saturation current காக it is completely depending upon the intensity. Okay, intensity increases na saturation current also increases. அது கூட you should know. Okay va? So இப்போ வந்து we are going to discuss about the failure of wave theory. Okay, failure of wave theory. So இப்போ வந்து according to wave theory one important thing is like இந்த எலக்ட்ரானுக்கு எனர்ஜி இது வந்து கண்டினியூஸ் டிஸ்ட்ரிபியூஷன், அந்த எனர்ஜி கண்டினியூஸ் டிஸ்ட்ரிபியூஷன், அதுக்கு வந்து இட் ரிக்வயர்ஸ் மோர் டைம். ஓகே, ஆனா வந்து we know that in the photoelectric effect வந்து it is a instantaneous process. Okay, it is a instantaneous process. It is an instantaneous process na and the time வந்து nanoseconds la irukku, 10 to the power minus 9 seconds and the fraction of second la in the process முடிஞ்சிடும். and according to wave theory இதுக்கு வந்து கொஞ்சம் time எடுக்கிற process தான். அப்போ வந்து we cannot explain this. and also in the stopping potential and frequency it is related. and according to wave theory இது வந்து there is no relation. Okay, ஆனா வந்து இந்த stopping potential should depend upon intensity. Okay, ஆனா வந்து we know that there is no dependence of intensity for the stopping potential. Okay, stopping potential. Understood? Everybody got it? So இதுதான் வந்து இந்த wave theory fail ஆகனதுக்கு reasons இதுதான். Next வந்து we know in the particle nature na photons da. இப்போ வந்து if a light is interacting with another wave, it should show the wave property. When it is interacting with matter, it should show the particle nature. And the particle nature da whatever we have mentioned, it is nothing but the photons. Okay va, in the photons. இப்போ வந்து we should know that in the particle nature nalum, and we were discussing about the momentum. Correct, we were discussing about the momentum. and the momentatoda value enna, and the momentum particle ku momentum irukku. and the momentum வந்து what is the momentum? Tell me in the chat box. And we know the energy is h𝐻𝐵. So இப்போ வந்து you should tell me what is going to be the momentum of the photon. It is nothing but tell me what is going to be the momentum. You should know it. What is the momentum? அது வந்து P is equal to mv வந்து ப்ராப்பரா இந்த பார்ட்டிகிள்க்கு. இப்போ வந்து we are talking about இந்த waves-ல இருக்கிற பார்ட்டிகிள். So that is nothing but h by lambda. Okay, so அந்த photonோட what is in the momentum வந்து it is nothing but h by lambda. So you can see that in the momentum na அது particle property da, and அது define பண்ணி இருக்கிற way if you are just checking on it h by lambda na part wave nature, wave க்கு தான் அந்த lambda இருக்கும். So அதனால we can say that this is justified, or let's say in the left hand side la particle nature, ஆனா அந்த particle nature is defined by a wave property, or let's say wave nature. Okay va. So இப்போ வந்து I'm just going to discuss about matter waves or de Broglie waves. Okay, so இப்போ வந்து இந்த பார்ட்டிகிளுக்கு wave nature இருக்கு. Okay, இந்த பார்ட்டிகிளுக்கு வந்து wave nature இருக்கு. ஆனா வந்து we cannot see that in a bigger objects and everything. ஆனா வந்து electron, neutrons அதுல வந்து we can see this matter waves, or we can say that in the matter waves இல்லனா we can say that de Broglie wave. Okay, so அந்த matter wave ஓட அந்த matter wave ஓட wavelength வந்து h by p, or let's say h by mv, or let's say we can say it is nothing but 2me. na nothing but kinetic energy. ஏனா we can just write. So in the equation if you are just checking on it, we are talking about matter waves. Correct? we are talking about matter waves. So in the right hand side la wave property lambda is there. Ana vandu if you are checking on the right hand side and the wave oda what is a wavelength decide பண்ணும்போது in the right hand side la particle property da we are discussing. H by P na momentum na adu particle related. So in the left hand side la wave nature and right hand side la adu define பண்றது வந்து particle da. So you can just write it like this, and also you can just whatever be the equations we are getting for the energy, we can just substitute and we will be getting the values. Okay. Okay, so these are the things we should study in the dual nature chapter. Okay, so இப்போ வந்து we have roughly we have covered 4 chapters. இதில் வந்து we have just focused the important parts and what we should know while we are going for the exam, and whatever I have taught, at least study that. That will help you to get a good marks. Okay, and நாளைக்கு வந்து we are going to discuss some of the question papers. Okay, I have created some question papers for you. So on the question paper da we are going to discuss, and in the session in the session kulla we will be getting in between you will be getting some study materials also. So miss pannama you should go through each and everything, and that will be yes, momentum will be h by lambda in the other case. Any other session இன்னைக்கு physics க்கு session இல்ல. Okay, okay va. So இப்போ வந்து you can go for studying all the equations, everything whatever we have discussed, and in the E again you can just keep it to QV ஏனா இந்த energy வந்து charge into potential. Also you can just rewrite in terms of temperature 3/2 kBT, so you can just go for that as well. So whatever it may be you should study everything properly. Otherwise இது வந்து difficult ஆக போற. Formulas வந்து revise பண்ணிக்கோ. Derivations at least on the last day, third day you have to go for it. Otherwise na you will struggle. No one else is going to help you. No miracle is going to happen. No magic is going to happen. அதனால வந்து guys, don't forget, study. Don't waste a single time. In the class you have seen, and I have to take notes also. இப்போ வந்து you are not reading the notes, if you are not doing any problems na, if you I will say you wasted the session. Okay, so அதனால தான் சொல்றேன், tomorrow வந்து session time will be 5. Okay, 5 the timing. Okay va. So don't waste a single minute. Study well and don't stick with the mobile. Okay, you just go through the notes, study. Formulas you should go for. Formulas you will be remaining lessons, Jenny, we can just do it on 19th. Okay, 19th anyway we are doing the Mahamarathon, right? So in that the chapters which I have skipped, we can go little detail because all the chapters were the small chapters da. Okay, adanala vanda that is not going to be a big deal for us. We can solve it. Okay va. Okay, we can sort it out. Okay Jenny. Okay va. Evening only on Thursday we will be having at 11. Okay, Thursday exam ku one day before 19th ku we will be starting from 11 and we will cover all the chapters and we will cover many more questions. Adu vandu quick revision a irukum, and we will go for some of the important questions ena time limits irukku. So adanala vandu we will be just focus on few things and we will get an idea about the whole physics. Okay va. So adha I have planned for it, and also atom nuclear, that is what I said, we will finish on 19th. Okay, so adellam vandu 30-45 minutes the max to max we will take. Okay, so see you guys, all the very best. Miss பண்ணாம time waste பண்ணாம study பண்ணிக்கோ. அதனால இல்லனா you will struggle. Okay, nobody is going to take the responsibility. It is your responsibility. Tomorrow வந்து question solving மட்டும்தான். Concept revision at present we are just saying bye to the concept revision. So ஏதாவது concepts required na the question discuss பண்ணும்போது I will help you. And 19th live it is at 11 AM we will be starting, and we will try to cover max to max whatever we can, we will cover. The rest we can think about it. Okay, so see you guys, see you and bye all the very best. Good night. You should get a proper sleep and healthier you should sit. Okay, don't go for junk foods and all. ஏனா இந்த last 3-4 days வந்து crucial இருக்கு. Okay, even 20th morning கூட we can study. So அதனால தான் சொல்றேன், இது வந்து what to say very very important crucial ஆன time தான். So இதில் வந்து if you have headache, if you have stomach pain, if you have fever, then the complete whatever you have planned, it will be going to be a very I mean it is going to be the journey is going to be difficult. Okay, so be healthy and drink a plenty of water. Also don't stick with mobile. Go around, walk around and do the things which you like. Okay, at least 15-10 minutes you should take a break in between every hour, or let's say every 1.5 hours. Okay, so see you guys. Bye. Thank you so much.